You're standing at the bottom of the world, or at least it feels like it. The air is razor thin and colder than logic. Your breath crystallizes in front of you before you can even feel it leave your lungs. All around is white, not the clean white of paper or walls, but a blinding endless glare that reflects from every direction, like some ancient mirror meant to confuse your senses. There's no horizon, just a blur between sky and snow, and not a single tree bird or breath of color to mark your place in it. Welcome to Antarctica. No buildings, no roads, no friendly campfires or tourist gift shops. Just the wind, the silence and ice so ancient it has trapped air from the time of woolly mammoths. The continent stretches more than 5 million square miles, about twice the size of Australia, and yet it feels like nobody's truly ever been here. Not really. Not beneath the surface. That's where the mysteries begin. Antarctica isn't just a place on a map. It's a frozen time capsule locked away from the rest of the world for millions of years. Beneath those endless sheets of ice, a mountain range taller than the Alps that nobody's seen with their own eyes. A lake the size of New Jersey that hasn't touched the atmosphere since early humans first figured out fire. Creatures that live in pitch-black waters under glaciers where the sun hasn't shone in more than 100,000 years. Some of them are alive. Some of them might not be entirely dead, and you probably won't survive this. Not without a space heater, 6 thermoses of tea, and a sense of humor about frostbite. But lucky for you tonight, you don't need snowshoes or survival gear. All you need is a blanket, a bit of curiosity, and maybe the willingness to ask a few uncomfortable questions. What if the things buried here don't want to be found? What if the continent is changing faster than we can keep up? And what if the real danger isn't the cold? So, before you get comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. Leave a comment with your location and local time. I love seeing where everyone's tuning in from around the world. Now turn off the lights, maybe turn on the fan for some soothing noise, and let's get started on tonight's journey together. You shuffle through the crunching snow. The air presses in around you. In the distance, a shape begins to rise. Not a mountain, not quite, but something. Something that shouldn't exist under miles of frozen silence. And still, it's calling. The ice groans beneath your boots. It doesn't crack or split. Not yet, it just groans. A deep, vibrating sigh that pulses up through your legs like a slow exhale from the Earth's chest. You pause. That wasn't wind. That was something below. You're standing atop a place where no one has ever walked, not really. Because if you were to start digging right now, ice pick, shovel bare hands, it would take you hours just to break through the first 100 feet, then hours more, and then days. Because what lies beneath you isn't just cold, it's 4,000 meters of compressed ancient ice. Ice that's older than civilization, older than language. Ice that doesn't want to be disturbed. But if you could keep going down through the frozen centuries, you'd eventually hit something unexpected. Not ocean, not molten rock, but mountains. That's right. Antarctica has mountains. And not just any mountains, an entire range stretching hundreds of miles across the eastern part of the continent. You can't see them. No one can. They're buried beneath 2.5 miles of ice. But they're there. We've heard them. We've scanned their shadows. We've even named them the Gomburtsev subglacial mountains. A name that sounds like a cough and a mystery rolled into one. These are not gentle hills or worn-down ridges. By all estimates, they're sharp, jagged. Some peaks may rival the Alps in elevation, and yet they are invisible. So why does Antarctica have a mountain range buried so deep that no one knew it was there until 1958? That's the million-year-old question. The mountains were first detected using radar Cold War era Soviet scientists bouncing signals off the ice and getting odd echoes back. Something solid, something massive, something that didn't belong. Since then, satellites and ground-penetrating radar have given us a blurry X-ray of the shape below. But it's like trying to understand a sculpture by the shape of its bubble wrap. The details remain locked beneath an icy vault. Geologists believe the Gamburtsev Mountains may be older than the continent's ice itself, possibly over 500 million years old. They may have formed during the collision of ancient continents back when the supercontinent Gondwana was just starting to piece together, like a slow-moving jigsaw puzzle. Imagine this before the dinosaurs, before the coal swamps, before fish had bones. This mountain range was already standing. And now, it sleeps beneath a frozen tomb. Here's where it gets weird. Most mountain ranges erode over time. Wind, water, earthquakes, nature wears them down. But the Gamburtsevs are still sharp, still pointy. That shouldn't be possible, unless something has preserved them perfectly for hundreds of millions of years. Unless the ice didn't just bury them, it embalmed them. Scientists are baffled. Some think the mountains acted as a kind of nucleation point for the Antarctic ice sheet, that the ice first formed around them like frost spreading from a single cold stone. Others argue the mountains came later, pushed up by tectonic forces under the already frozen crust. But no one knows for sure. Historians still debate whether these hidden peaks played a role in the initial freezing of the continent itself, and what might lie inside these mountains. That's the question that keeps glaciologists up at night. Not just rock, maybe not just fossils, but whole ecosystems preserved crushed and cryogenically frozen. Picture a valley filled with ferns, maybe even insects. Creatures that thrived during Antarctica's green past, caught in a sudden blizzard and locked away forever. If those remains are there, they could completely rewrite the story of Earth's biosphere. They could show how life responded to planetary-scale cooling. They could even tell us how life might survive on frozen exoplanets circling distant stars. So naturally, we want to drill, but that's the problem. You can't just stick a straw into a 4-kilometer ice cake and hope for answers. Drilling into subglacial areas is risky. The pressure is enormous. The temperatures are savage. And perhaps most concerning, the possibility of contamination. If there is life down there, ancient microbes or dormant spores introducing surface bacteria could destroy it. It would be like sneezing into a tomb before you knew what lay inside. That hasn't stopped us from trying. In recent decades, researchers from around the world have coordinated to map the area. Britain, Russia, China, the US. They've all sent radar surveys, ice cores, and seismic studies into the region. They've even used planes equipped with magnetic sensors to detect the gravitational fingerprint of the mountains below. So far, the mystery only deepens. Some parts of the range appear unusually warm, as if geothermal energy, heat from the Earth's mantle, is seeping up through the crust, creating pockets of liquid water beneath the ice. Not oceans, but rivers, lakes, entire hydrological systems moving in secret darkness. And wherever there's water, there could be life. Strange, adapted, lightless life. One day, when the technology is ready, we may send autonomous submarines down these glacial channels to explore the valleys of the Gamburtsevs. Until then, we wait. We measure. We dream. Tonight, as you stand in the silence, just imagine the scale of what's hidden beneath your feet, a mountain range older than memory, taller than belief, and colder than any place on Earth. No wind reaches it. No sunlight touches it. But it's there, waiting, watching, and you can almost hear it breathing. The wind picks up again, brushing across your shoulders like a cold whisper from something ancient. But this time, the cold doesn't scare you. Not when there's fire beneath your feet, because rising from the ice like some colossal steaming guardian of the underworld is Mount Erebus. You'd be forgiven for thinking volcanoes and Antarctica shouldn't go together. Fire and ice lava and snow, it sounds like a contradiction. But Erebus doesn't care about your logic. It burns anyway. It always has. Mount Erebus is no ordinary volcano. Perched on Ross Island near the edge of the continent, it stands nearly 12,500 feet tall, but its true claim to fame lies at the top. Unlike almost any other volcano on Earth, Erebus has a persistent lava lake in its summit crater. That's right, boiling molten rock that never cools, even though the surrounding temperatures can drop to 60 degrees. Talk about showing off. And it's been doing that for thousands of years. Discovered in 1841 by British explorer James Clark Ross Erebus, was named after the Greek god of darkness, an ominous choice that turned out to be surprisingly accurate. The volcano has erupted regularly since its discovery. Some of those eruptions are minor, just a cough of ash into the sky. Others, well, let's just say Erebus doesn't always give a warning. But what makes this volcano so fascinating isn't just that it exists in such a brutally cold environment, it's how alive it is. That lava lake bubbles and turns like a simmering soup of the underworld. Occasionally, it hurls volcanic bombs, glowing hunks of molten rock hundreds of feet into the air. Some land back in the crater, others not so lucky. Still, scientists flock to Erebus. Why? Because it's one of the best natural laboratories in the world. You stand there now, just close enough to feel a strange warmth cutting through the wind. The snow around the rim of the crater hisses as it melts into steam. The air smells like sulfur and stone. Researchers in thick suits crouch by strange machines, measuring the gases rising from the volcano. CO2 sulfur, dioxide water vapor. These aren't just emissions. They're clues. Clues to what's happening beneath the Earth's crust. You see, Erebus offers scientists a rare view directly into the Earth's mantle, that hot churning layer where tectonic plates are born and continents drift like lazy icebergs. By studying Erebus's eruptions and the chemistry of its gases, geologists can learn more about how magma forms, rises, and explodes. In a way, Erebus is like a periscope into the heart of the planet, but even more curiously, it's also whispering into space. Erebus is one of the few volcanoes whose gas emissions can actually be measured by satellites orbiting overhead. That's right, from hundreds of miles above, scientists can detect tiny plumes of volcanic gas rising from this frozen land. It's like a signature, a pulse, a volcanic heartbeat visible from the void. Still, as with all things in Antarctica, the story doesn't end there. You walk further along the base of the mountain and notice something strange, glaciers curling around its lower slopes, like icy snakes coiling near a fire. At first it seems peaceful. The glaciers melt slightly, then refreeze. But as the climate changes and temperatures rise, this interaction grows more dangerous. Some scientists believe that the heat from Mount Erebus may be weakening parts of the surrounding ice shelf. Not enough to melt it outright, but enough to destabilize. It's like placing a furnace beneath a frozen ceiling. Sooner or later, cracks start to form. And when they do, the effects can ripple for miles. Historians still debate whether Erebus's geothermal heat could play a larger role in Antarctic ice loss. It's not the only factor global warming ocean temperatures and changing weather patterns all contribute. But Erebus is part of the equation, a fiery wild card in a frozen deck. And then there's the sound. If you stop and listen, really listen, you'll hear more than wind. The crater emits deep rumbles. Some are caused by gas bubbles collapsing inside the lava lake. Others are seismic, echoing through the stone. But some seem different. Infrasound. Vibrations too low for human ears, picked up only by specialized sensors. Scientists monitor these like stethoscopes pressed to a sleeping dragon, because one day that dragon might wake up. Erebus has claimed lives before. In 1979, an Air New Zealand sightseeing flight crashed into its side during whiteout conditions, killing all 257 passengers and crew. The disaster shocked the world and forever linked the mountain to both awe and tragedy. The wreckage still lies buried under snow and ice, a solemn reminder that Antarctica does not forgive mistakes. But the mountain endures. Through storm and silence, Erebus continues to burn. Its lava dances like a beacon, defying the cold, reminding us that not everything beneath the ice is frozen. Some things, a few rare molten things, burn on. You back away slowly from the crater rim. The heat has vanished. The wind returns. And once again, the overwhelming white silence surrounds you. Only now, you carry a secret that even in the coldest corner of the earth, the fire still lives. And it's watching. Your breath rises in soft plumes as you step away from the warmth of Mount Erebus. The chill returns, quickly curling around your fingers and nose like a living thing. You pull your coat tighter and glance out across the ice-flat blue-white stretching in every direction like a frozen ocean. And then movement. At first, it looks like a crack in the snow. Then it stands, waddles, flaps. You blink. It's not a crack. It's a penguin. And then another and another. They arrive in a slow, deliberate parade, marching with the gravity of royalty and the awkwardness of sleepwalkers. Emperor penguins, the largest and most famous of their kind, dressed in formal wear, as if every day is a wedding and a funeral all at once. They don't notice you, or maybe they do, and they simply don't care. Because here in Antarctica, they are the natives. You're the tourist. Despite the cold, the wind, the darkness that stretches on for months, these birds choose to live here, to thrive here, to raise their young in the harshest conditions on the planet. You watch as one parent takes a slow, careful step, balancing an egg on its feet, hidden beneath a flap of warm belly skin. That tiny egg is the future, and it's surrounded by an empire of ice. Emperor penguins are the only species of penguin that breed during the Antarctic winter. That's right, while every other living thing is heading north for the season, these birds lean into the freeze. Temperatures can drop to 60°. Winds can howl at over 100 kilometers an hour. But the penguins stay. They huddle. They endure. They survive. And they're not alone. In the distance, a shape slips from the ice shelf into the ocean with barely a splash. A Weddell seal gliding like a ghost through the water, chasing fish under the ice. These seals are champion divers. Some have been recorded plunging more than 600 meters deep and holding their breath for over an hour. You try holding your breath for 30 seconds and suddenly feel very, very unimpressive. But that's the magic of Antarctic life. It's not flashy. It's not colorful. It's resilient. These creatures have adapted to live in a world that would kill most species in minutes. They have thick layers of blubber for insulation, blood that keeps flowing even in freezing temperatures, vision adapted for hunting in near-total darkness. And in the case of emperor penguins, social structures so sophisticated they put some human families to shame. You watch as dozens of penguins huddle together, a mass of feathers and warmth constantly shifting, so no individual stays on the outside for too long. It's not just cute, it's a survival mechanism. These birds understand something very simple and very profound. You live longer when you care for each other. It's easy to romanticize them. The tuxedos, the waddling, the parental devotion. But don't be fooled, they are warriors. Every year, thousands of them survive a gauntlet of hunger, cold, and predators to raise their chicks. It's a brutal, beautiful rhythm. One wrong step, one cracked egg, one missed meal, and the entire season is lost, and it's not getting any easier. You look around and notice something subtle. A piece of sea ice floating loose, a slushier texture near the shore, a patch of exposed rock where there used to be snow. The signs are quiet, but they're growing louder. Antarctica is changing. It's not just an environmental problem, it's a chain reaction. Already, scientists are seeing signs of stress. Emperor penguin colonies have suffered mass chick die-offs due to unstable ice. Certain seal populations are moving farther south in search of colder waters. And the whales, those ancient travelers of the Southern Ocean, are altering their migration routes. Slowly, reluctantly. Historians still debate whether previous warming periods were as sudden as what we're seeing now. But what's not up for debate? This one's happening fast, and the animals feel it first. You crouch beside a penguin and try to imagine what this landscape would look like without them. Without their awkward charm, without their determination, without their quiet, flippered testimony to the endurance of life. You don't like the image, and neither do the scientists. That's why they're working fast, studying migration patterns, tagging seals with satellite trackers, flying drones over colonies to monitor numbers. Some researchers live on the ice for months at a time, risking frostbite and isolation just to understand what's happening before it's too late. You stand brushing ice from your gloves. The penguins keep marching oblivious, or maybe wise enough not to care. They've been doing this for thousands of years, but how many more? In the water, a shape surfaces. Smooth, enormous. A blue whale gliding like a continent through the sea. The largest creature to ever live on Earth. Its exhale bursts into the sky like a geyser. Then it vanishes. In that moment, you realize something. Antarctica may seem empty, but it's not. It's teeming. You just have to be still enough to notice, and just quiet enough to hear it breathing. You move farther inland now, away from the shoreline cries of seals and the marching chorus of penguins. The wind sharpens, slicing through your jacket with the indifference of time. The horizon grows flatter, whiter, quieter. It feels like you're walking across a blank page, except, of course, the story is already written beneath your feet. The snow here lies heavy, unmoving. But buried far below, under more than 4,000 meters of ancient ice, another mystery sleeps. You wouldn't know it by looking. There's no hint on the surface, no rising peak, no jagged outline against the sky. Just the same flat sheet of glacial stillness, but beneath it, the Ellsworth subglacial highlands. The name sounds ordinary enough, almost polite, but don't be fooled. What's hidden down there isn't just a set of hills. It's a shattered, tilted, broken skeleton of an ancient mountain range. Peaks and valleys frozen under millennia of ice. Entire landscapes compacted like fossils inside a glacier. These aren't the same as the towering Gamburtsev Mountains you passed earlier. The Ellsworth Highlands are older, quieter, and possibly even more enigmatic. Scientists believe they are the leftovers of a time when Antarctica looked nothing like the icy tomb it is now. When trees grew tall, when rivers ran unfrozen, when creatures you've never even imagined crawled hunted and swam across these now buried slopes. Geologists speculate that the Ellsworth Highlands may date back hundreds of millions of years, perhaps even to the time of Gondwana, the ancient supercontinent that once fused what we now call South America, Africa, Antarctica, India, and Australia. Back then, the land under your boots wasn't alone. It was part of a lush living world. A green Antarctica, and then came the cold. The ice didn't fall all at once. It crept. It blanketed. It crushed. Whatever lived in the highlands forests, insects, perhaps early reptilian forms, was slowly erased layer by layer. The land went quiet, and then it vanished from view altogether. Until very recently, with new advances in ice-penetrating radar and satellite topography, scientists are starting to see through the ice. What they're finding beneath the West Antarctic ice sheet is a landscape more dramatic than anyone imagined: mountain basins, narrow ridgelines, steep cliffs, and something else, something liquid. There are subglacial lakes in the Ellsworth Highlands, entire bodies of water trapped beneath kilometers of ice, kept from freezing solid by the pressure and geothermal heat of the earth below. They haven't touched the sky in over 1 million years. They haven't been part of the water cycle. No rain, no evaporation, no rivers in or out. They are isolated world's closed systems and possibly alive, not with fish or seals or anything with eyes, but with microbes, the tiniest life forms, the kind that can survive in boiling acid or deep sea trenches, the kind that doesn't care whether it's day or night, summer or winter, because it's always been dark, always been cold, always been now. Scientists are desperate to reach those lakes, but it's not easy. Drilling through thousands of meters of sterile ice without contaminating the pristine water below requires technology so precise it's been compared to space missions. In fact, some of the same tools used to plan for Martian exploration are being tested here. That's no coincidence. Because if life can survive beneath Antarctica's ice, it might also survive beneath the icy crust of Europa, one of Jupiter's moons, or on Enceladus orbiting Saturn. What we learn here could teach us what to look for out there. And then there's the question of the fossils. You stare out across the ice, imagining what lies frozen beneath. Fossilized roots, ancient pollen, petrified wood from long dead forests, maybe bones, the scattered remains of some prehistoric amphibian or unknown species twisted beneath pressure and time. If those fossils exist, they could offer the clearest window we've ever had into pre-glacial Antarctica, a world so alien compared to today, it might as well be another planet. But all of it, the lakes, the rocks, the fossils, remains sealed for now, because the ice is melting, not everywhere, not rapidly. but it's happening. And the Ellsworth Highlands are becoming part of that global transformation. As the West Antarctic ice sheet loses mass due to warming oceans and shifting winds, water moves differently beneath the ice. Subglacial rivers previously frozen are starting to flow again. That movement affects the stability of the ice above, which could trigger collapses, changes in sea level, and the unveiling of secrets long buried. Historians still debate whether these changes are unprecedented or simply part of a natural cycle. But the current data is hard to ignore. And if the highlands emerge blinking and dripping into the 21st century light, we may not be ready for what we find. Some scientists believe we could discover completely new branches of microbial life. Others warn of ancient bacteria, harmless back then, but potentially dangerous, now awakened from their icy prison. Still others focus on the geological record. If we can get our hands on unweathered rock from those mountains, we might finally understand how and when Antarctica split from its sister continents. We could quite literally rebuild the ancient map of Earth. But you're just standing here on an endless field of white, listening to the silence, a silence that isn't quite empty. Somewhere far below, you water pulses. Ice shifts. A forgotten mountain exhales. And just for a moment you wonder, if something down there is listening back, you feel the cold in your teeth now. It presses inward from every direction, wrapping your breath in crystals and turning your eyelashes to frost. You've grown used to the silence, that deep padded stillness that only a place like Antarctica can offer. But what you're standing over now isn't silent. It's sealed. There's a difference. Far beneath your boots, under 4 kilometers of ancient glacial ice, lies one of the most isolated and enigmatic places on Earth, Lake Vostok. You wouldn't know it's there. From above, it's just another stretch of white. But under that ice, nestled like a secret, is a body of water the size of Lake Ontario. It's been cut off from the rest of the world for 15 million years. No sunlight, no surface air, no seasons, nothing. And that makes it a scientific treasure and a biological time capsule. You shuffle forward, looking out across the snow-covered plateau. Somewhere in this unmarked field, scientists drilled down into the ice. They weren't trying to wake anything. They were listening, sampling, hoping. Because for decades, researchers had speculated about what might be hiding in that subglacial lake. Not just water life, tiny life, sure. No fish or coral reefs, but perhaps microbes. Maybe something microbial and ancient, suspended in cold darkness since long before humans ever existed. Creatures that never evolved under a sun. Creatures that learned to live without it. Lake Vostok wasn't even discovered until the 1970s, not directly at least. Soviet scientists noticed unusual radar reflections beneath the ice near Russia's Vostok station. It took years of analysis to confirm what they were seeing: a vast liquid lake trapped beneath an unbroken sheet of ice. A world within a world. Imagine that an entire lake sealed off for millions of years, hidden beneath a frozen desert. Getting to it would take decades more. Drilling began in earnest in the 1990s. But progress was agonizingly slow, both technically and ethically. Sea drilling through kilometers of sterile ice risks, contaminating the lake below. Drop just one foreign bacterium into the water, and you ruin the sample forever. So researchers developed specialized clean drilling techniques, hoping to melt down through the ice without compromising what lay below. In 2012, the Russian team finally broke through. They didn't hit the lake directly, not yet. What they reached was refrozen lake water, pushed up into the borehole under immense pressure. It was a victory, but a cautious one. When the samples were retrieved, scientists analyzed them for traces of life, and they found it. Microbial life, possibly ancient, possibly unique, but, and here's the kicker, it's still debated. Some argue that the microbes discovered were contaminants introduced by the drilling equipment. Others believe they truly came from the lake itself. Either way, the result was enough to spark global fascination. We hadn't just drilled into a lake. We drilled into Earth's deep past, and perhaps into its reflection. Because Lake Vostok in many ways isn't just a curiosity, it's an analog, a stand-in, a model for alien oceans we haven't explored yet. Like Europa, the icy moon of Jupiter, where a frozen surface covers what is believed to be a vast subterranean sea. Or Enceladus, circling Saturn, which shoots geysers of water vapor into space from cracks in its icy shell. If life exists in Vostok, sealed, isolated, surviving in total darkness, in crushing pressure, then maybe it can exist out there too. That's why astrobiologists are obsessed with Antarctica. It's not just Earth's last frontier. It's a preview of another world. Back on the ice, you kneel and press your gloved hand to the ground. Somewhere beneath you lies water, untouched by sun or sky. A lake kept liquid by pressure and heat from the Earth's core. It has its own chemistry, its own currents, maybe even its own evolution, and still it sleeps. Historians still debate whether ancient microbes from places like Vostok could teach us about Earth's earliest life. Some believe these organisms might resemble the first life forms ever to evolve, anaerobic extremophilic, clinging to volcanic vents or chemical gradients. Others wonder if they represent a divergent branch life that's been evolving independently under the ice since long before mammals walked the land. But the possibilities don't stop there. If we discover truly alien biochemistry in Lake Vostok, something totally different from the rest of Earth's life, it would suggest something shocking, that life doesn't just adapt to survive. It invents itself anew wherever it can. And yet, for all this speculation, the lake remains almost entirely untouched. Less than 0.1% of its water has been sampled. We don't know what else lives there. We don't know how deep it goes. We don't even know if the lake is static or dynamic, whether it has currents, whether it connects to other subglacial water systems, or whether it changes with the seasons. If you think Antarctica is quiet, try a lake that hasn't spoken to the atmosphere since saber-toothed cats were a thing. It's like trying to study a ghost through a keyhole. Still, the work continues. New missions are planned. New technologies are in development, including sterilized robotic probes that may one day dive into Vostok's inky depths. And when they do, they'll be looking for more than life. They'll be listening, because what lies beneath the ice might not just inform us about biology. It could speak to something deeper about isolation, resilience, and the memory of a planet that forgets nothing. You rise to your feet. The cold crackles around your joints. Above you, sky. Below you, silence. And under that, a lake pulsing gently in the dark, waiting. The wind picks up again, tugging at your sleeves like a nervous child. But you're not listening to the surface anymore. Not really. Your mind is drifting downward through layer after layer of frozen time into something darker, deeper, more profound, because you've come to a place few people even know exists. The Denman Glacier Trench. It doesn't roll off the tongue like Vostok or Erebus. It doesn't have the poetry of a name like Blood Falls or Lake Whillans. But don't let that fool you. This trench, this hidden chasm beneath the Antarctic ice, may be the most shocking landscape on the planet. You're standing above it now, though there's no sign, no marker, just flat ice. But if you could drop through the surface, you'd fall more than 3,500 meters deeper than the Grand Canyon into a gaping geological wound carved into the Earth's crust. A place that, if exposed, would be the lowest point on land anywhere on Earth, even lower than the Mariana Trench, if it weren't filled with ice. The Denman Glacier Trench was discovered using ice-penetrating radar and gravitational mapping, a sort of planetary X-ray that reveals the unseen contours beneath Antarctica's thick white shell. What scientists found wasn't just a glacier. It was a hidden abyss plunging farther than anyone thought possible. And like so many Antarctic mysteries, it's not just about the depth, it's about the danger, because this trench, shaped by ancient tectonic forces and sculpted by millennia of ice flow, is a potential weak point in the Antarctic ice sheet, a place where warming waters and shifting ice could trigger a domino effect with global consequences. Let's break that down. Above the trench lies the Denman Glacier, a slow-moving river of ice over 100 kilometers long. To the untrained eye, it looks solid static, but it's anything but. That glacier is retreating. Fast. Not because the air is warmer, though it is, but because the ocean beneath is changing. You see, warm ocean currents are sneaking under the floating edges of the glacier, melting it from below. This process is called basal melting, and it's incredibly dangerous. The more ice melts underneath, the more unstable the glacier becomes. Eventually, it begins to collapse inward, like the roof of a cavern slowly caving in. And here's where things get unnerving. The walls of the Denman Trench slope downward toward the interior of the continent. That means as the glacier retreats, it moves into deeper and deeper territory, a phenomenon known as a retrograde bed slope. Once it hits a certain tipping point, the retreat could accelerate, fast, irreversibly, like a ball rolling downhill with no brakes. Scientists estimate that if the Denman Glacier were to collapse entirely, it could raise global sea levels by 1.5 meters. That's 5 feet. Enough to redraw coastlines, enough to flood entire cities, enough to force millions of people to migrate inland. And that's just one glacier. Historians still debate whether Earth has experienced collapses like this in the deep past, whether sea levels have ever risen so dramatically so fast. Some models suggest yes. Others warn that what we're seeing now might be unprecedented in speed. Either way, Denman is a blinking red light on the climate dashboard, and it's one we're only just beginning to understand. But beyond the climate threat, there's a different kind of mystery. Beneath that glacier inside the trench itself are subglacial lakes, pockets of liquid water trapped under unimaginable pressure. These lakes may have been sealed off for millions of years, just like Lake Vostok. They may hold ancient microbial life adapted to darkness, cold, and isolation. Or they may be completely sterile, lifeless tombs, filled with the memory of a different Earth. No one knows for sure. No one has been there. Some scientists dream of sending robotic probes down into the trench, not just to monitor the ice, but to explore the geology, the microbiology, the chemistry. They imagine autonomous submarines navigating blind through the abyss, collecting samples from a world no human has ever touched. Others whisper of even stranger possibilities. Could the trench hide evidence of ancient climates buried in sediments at the bottom? Could it contain the fossilized remains of plants, animals, even entire ecosystems lost beneath the first waves of ice that claimed the continent millions of years ago. Could it just maybe tell us what Antarctica looked like before it froze? It's hard to say, but the curiosity is real, and the technology is catching up. For now, Denman remains a sleeping giant both scientifically and metaphorically. A crack in the planet's shell, a riddle written in ice, a place where geology, biology, and climatology collide in one single terrifyingly quiet trench. You kneel on the surface, now your breath sharp and white against the bitter air. There's nothing to see, no sound but the wind. But beneath you lies a void, a depth so extreme it warps the gravitational field around it. A canyon so vast it could swallow cities whole. A silence so complete it has never once been broken by the sound of human life. And still the glacier moves, slow, relentless, unseen. You close your eyes and imagine the creak of ancient ice sheets shifting over that trench millimeter by millimeter, day by day. You imagine the cold water pooling beneath, the sediment stirring, the microbes waking. The abyss is real, and it's rising. You don't feel it at first. The shift is too slow, too massive, too ancient to register in a single breath. But as you look out across the frozen landscape, your eyes catch something subtle, a curve where the ice shelf should be straight. A wide, soft sag like the surface itself is exhaling. This is Thwaites Glacier, or as some have started to call it, the Doomsday Glacier. That nickname isn't just clickbait. It's earned. Because of all the glaciers in Antarctica, this one might be the most important and the most terrifying. Not because it's the biggest, though it's massive, and not because it's melting the fastest, though it's melting fast, but because if it goes, it might take the entire West Antarctic ice sheet with it. Let's paint the picture. Thwaites stretches more than 120 kilometers across and flows into the Amundsen Sea. That's like a frozen river, wider than the state of Delaware, moving slowly but steadily into the ocean. Beneath it lies a complex network of channels, soft sediment, and warm water. The kind of geology that doesn't like to stay put. And here's where things start to unravel. Warm ocean currents are sneaking underneath the glacier's floating edge, melting it from below. It's the same basal melting that's destabilizing Denman Glacier. But here it's worse. The meltwater acts like a lubricant, allowing more ice to slide into the sea. And as the ice shelf thins, it loses its grip on the land behind it, kind of like a giant freezer door slowly unhinging. The scary part, once that door opens all the way, there's no closing it. Thwaites holds back enough ice to raise global sea levels by over 3 meters, nearly 10 feet. That's not just beachfront property getting wet. That's entire coastlines being rewritten. Cities like Miami, New York, Jakarta, Mumbai, gone or forced to build walls taller than most buildings. And it gets worse. If Thwaites collapses completely, it could trigger a chain reaction destabilizing nearby glaciers that are already teetering on the edge. Together, they hold enough ice to raise sea levels by more than 3 meters additional. That's the doomsday scenario scientists talk about, not because it's cinematic, but because it's alarmingly plausible. Historians still debate whether something similar happened during past interglacial periods, times when the Earth naturally warmed between ice ages. But what's happening now isn't just warming, it's speeding up. What used to take millennia is now happening in decades. You might expect this place to look like it's falling apart. Cracks, chaos, floods. But it doesn't. That's what makes it so unnerving. It looks calm, still, almost serene. The ice is so smooth, so quiet. You'd never guess the forces at work below. Like standing on a frozen lake without knowing it's melting from underneath. And the scientists, they're watching closely. Teams from the US and the UK have launched a joint mission called ITGC, the International Thwaites Glacier Collaboration. It's one of the most ambitious Antarctic research projects ever attempted. They've deployed autonomous submarines, drilled boreholes, placed GPS stations, and even dropped instruments from airplanes. What they're finding isn't comforting. The glacier is fracturing, not catastrophically, not yet, but enough to show that the ice is under stress. The grounding line, where the glacier lifts off the land and begins to float, is retreating inland by hundreds of meters per year. And the rate of ice loss, it's doubled in just a few decades. You watch from the edge of a frozen ridge as a team prepares to launch a robotic probe beneath the ice. It's shaped like a torpedo, built to swim blind under the glacier and report back from the darkness. What it finds will help determine just how long Thwaites has left. But even the best instruments can't see everything. Because ice-like time hides its intentions well, you kneel beside a crevasse. It's not large, barely wide enough to fit your boot. But it goes deep. So deep, you can't see the bottom. Just darkness. A darkness that shifts, groans, and waits. You listen, and beneath the silence, you hear it a low, drawn-out creak, like the first note of an old ship starting to break apart. A sound that should not be comforting. And yet it is. Because it means the glacier is still moving, still alive, still warning us. Some scientists say we have a few decades. Others say it's already too late to stop the collapse, only to slow it. Either way, the message is clear. What happens here doesn't stay here. The melting of Thwaites affects everyone, not just penguins and polar researchers, but farmers in the Midwest, families in coastal Vietnam, commuters in Manhattan. It's all connected. The ocean doesn't care about borders, and the glacier, it doesn't care at all. You rise to your feet, brushing snow from your knees. The sky above is vast and pale. The glacier beneath is ancient and shifting. Somewhere behind you, the sea waits. Somewhere beneath you, the land sinks. And somewhere ahead of us all, the water is coming. You walk a little slower now. Not because you're tired, though your boots are heavy and the cold has settled into your bones, but because something has shifted. The land under your feet no longer feels still. It feels like it's breathing, not in the way animals breathe, not even like wind rushing across an open plain. No, this breath is slower, colder, deeper. It's the breath of a sleeping continent, one that expands and contracts with the pulse of time itself. You've reached the Antarctic ice sheet, not just one glacier or trench, but the entire icy lung of the southern hemisphere. Spanning over 5 million square miles, this frozen beast covers roughly 98% of the continent. And unlike a lake or mountain, it's not still. It flows, moves, builds and collapses over cycles so vast they make the lifespan of empires look like hiccups. And it breathes. In the depths of winter, when the southern ocean churns with ice and the skies never brighten, the ice sheet grows. Sea ice fans outward in jagged fingers, stretching Antarctica's reach by more than 7 million square miles. In the summer, it recedes not dramatically, but purposefully. Like an old creature adjusting its posture in the cold. These seasonal shifts are ancient, normal, part of the Earth's rhythm. But something is changing. The breaths are becoming shallower. Each year, the ice sheet grows just a little less than before. Each summer, it retreats a little more. It's subtle, like a quiet cough in the next room. But for scientists who study the ice, it's as alarming as a skipped heartbeat to understand why you have to see the ice sheet for what it truly is: a memory. It holds within it hundreds of thousands of years of data, not in hard drives or books, but in ice layers compressed year after year, snowfall on snowfall. Like rings in a tree, each layer of ice preserves a tiny piece of the atmosphere it formed in traces of carbon dioxide, methane, even pollen and ash. Tiny bubbles of ancient air trapped in time. And the deeper you go, the farther back the memory stretches. Scientists have drilled ice cores more than 3,000 meters deep, unlocking climate records that go back 800,000 years. They've found periods of warming and cooling volcanic eruptions, even evidence of massive forest fires on other continents, all recorded by the snow that fell at the bottom of the world. But today, the ice sheet isn't just remembering, it's responding. Temperatures around Antarctica are rising. The ocean is warming. And the underside of the ice is beginning to melt in ways we didn't fully predict. It's like watching the breath of the continent become ragged, hesitant, as if something old is being disturbed. You pause to look at the horizon. In the distance, a massive wall of ice glows pale blue in the sun. It looks solid, eternal. But you know better now. The ice moves. Some places flow at several meters per day. Others are speeding up, straining, breaking. Historians still debate whether similar melt events led to past climate catastrophes. During the last interglacial period about 125,000 years ago, sea levels were 6 to 9 meters higher than they are today. It's possible that Antarctic melt was partly to blame. But back then, the process took thousands of years. Today, it's moving faster, too fast. In fact, one of the most surprising discoveries in recent years was that parts of the East Antarctic ice sheet, long considered stable, may also be vulnerable. Scientists thought it was safe untouched by warming waters. But radar imaging revealed subglacial valleys and basins that could allow ocean water to reach far inland. If that happens, East Antarctica, with enough ice to raise sea levels by dozens of meters, might start breathing differently too, and not in a good way. As you walk, you imagine the continent's breath as a giant bellows: inhale, exhale, expansion, contraction. For millions of years, this process helped regulate Earth's climate. When the ice grew, it reflected more sunlight, cooling the planet. When it shrank, the Earth warmed ever so slightly. But now, with human emissions, deforestation, and atmospheric carbon at record highs, the ice is struggling to keep up. The bellows are wheezing. The balance is tipping. And still, most of the world doesn't hear it. Antarctica's movements are too slow for a news cycle. Its creaks don't trend. Its collapses happen quietly, sometimes over months, with only a slight change in satellite data to mark them. But beneath that stillness is a message. The planet is changing, and the lungs of the Earth are not invincible. You stop and kneel, pressing your hand against the snow. There's nothing beneath your fingers but cold. But if you could listen long enough, still enough, you might hear it, the distant low hum of ice shifting thousands of feet below. Somewhere down there, a pocket of water drains through a melt channel. A glacier creeps another millimeter toward the sea. A bubble of ancient air rises slowly toward the surface. The continent breathes, and the rest of the world doesn't notice. Not yet, but you do. And now, you understand something few people ever do. Antarctica isn't just a place. It's a system, an organism, a memory, a warning, And like all living things pushed too far, it's starting to change its rhythm. So you rise, pull your hood against the wind, and take one more step forward onto a continent that remembers everything, even us. You blink against the snow glare, and something dark catches your eye, a black rock, just sitting there, alone on a field of white as if it had dropped out of the sky, which, as it turns out, it did. You crouch beside it. It's small, jagged, burned around the edges, like it's been through fire. And it has. Because this is no ordinary stone. This is a meteorite. A visitor from space, carried across the void, slammed into Earth thousands, maybe even millions of years ago. And now, it's just sitting here in Antarctica, waiting to be picked up. And this isn't rare. Antarctica, for reasons both strange and poetic, is the best place on Earth to find meteorites. Seriously, more than 60% of all known meteorites have been found on this frozen continent. Thousands upon thousands of them, from tiny flecks to grapefruit-sized hunks of iron and stone. Some are ancient fragments of the moon. Others hail from Mars. A few may predate the formation of Earth itself, and here in the ice they wait, perfectly preserved. Why here? Why Antarctica? Because the ice doesn't just freeze, it moves. Over time, the flowing glaciers of the continent act like massive conveyor belts. They trap falling meteorites and slowly drag them toward mountain ridges where the wind scours away the snow and exposes the rocks. Unlike other places on Earth, where meteorites get lost in soil water or forest, here they stand out like ink on a blank page, black on white, easy to see, easy to collect. You pick up the one at your feet and turn it in your hands. It's heavier than it looks. That's because many meteorites are made of iron and nickel-dense unearthly metal. It's cold now, of course, but this little rock once burned at thousands of degrees as it screamed through the atmosphere. Now it's just quiet. That quiet, of course, is deceptive, because inside this rock, buried in its cracks and minerals, are clues. Clues to how the solar system formed. Clues to how planets were born, collided, and evolved. Some meteorites contain carbon compounds, possibly the building blocks of life. Others hold microscopic crystals formed under conditions we've never recreated on Earth. And some might hold answers we're not even smart enough to ask yet. That's why scientists come here in droves. Every Antarctic summer expeditions head out on snowmobiles, towing sleds, scanning the ice for anything that doesn't belong. They camp in the cold log GPS coordinates, photograph each find, and bag the rocks for study. It's part science, part scavenger hunt, part galactic archaeology. One of the most famous finds came in 1984. A small gray meteorite was discovered in the Allen Hills region, cataloged as ALH 84001. It was eventually identified as a Martian meteorite likely ejected from the red planet by an ancient impact and flung into space. It drifted through the solar system for millions of years before crash landing in Antarctica. Years later, some scientists claimed it contained fossilized microbial structures, evidence maybe of ancient life on Mars. The claim sparked debate, excitement, even a speech by a U.S. president. But the jury's still out. Historians still debate whether the markings inside ALH 84001 are biological or just curious mineral patterns. But the question remains, what else might be waiting in these frozen fields? What other messages from space lie buried in the ice, unread and misunderstood? You place the meteorite carefully back on the snow. Around you, the wind hushes. The sun cuts low across the horizon, casting long shadows across the snow. In those shadows lie secrets from other worlds. And there's more to this story, because Antarctica doesn't just preserve space rocks, it delivers them. The continent's unique wind patterns and topography cause meteorites to accumulate in specific areas. The Transantarctic mountains act like natural collection trays, catching and concentrating meteorites carried by the ice. Some fields are so dense, researchers can collect dozens of meteorites in a single day. And as global interest in space increases, so does interest in these rocks. They're not just academic curiosities. They're time machines, chunks of the early solar system older than Earth, unaltered by atmosphere or erosion. They help us understand everything from asteroid formation to planetary chemistry. Some may even inform future space missions by showing us what we might find on Mars or what we need to prepare for on distant moons. But perhaps the most powerful thing about these meteorites is also the simplest. They're reminders that our world is not an island, that space is not silent, that even in the most remote, barren, lifeless place on Earth, the universe still finds a way to touch us. You rise, brushing frost from your gloves. Behind you, the meteorite glints softly in the snow. It doesn't belong here, and yet somehow it does, just like you. Because Antarctica isn't just about the cold, or the ice, or the ancient fossils locked beneath. It's about what falls from the sky. And what we find when we finally stop to look, the landscape begins to change. It's still Antarctica, still frozen and white and vast, but something feels different. The air is even drier here, if that's possible. The snow under your boots is gone, replaced by cold, bare rock and dust. No footprints, no ice cracks, just wind-polished stone and a silence so complete it rings in your ears. You've stepped into the dry valleys, Antarctica's most haunting and alien terrain. At first glance, it doesn't make sense. You're in the coldest place on Earth, and yet there's no snow, no glaciers in sight, just rust-colored hills, scattered boulders, and wide gravel-filled basins that look more like the surface of Mars than anywhere on Earth. And that's not an exaggeration. NASA literally tests Mars equipment here. This is a part of Antarctica that hasn't seen rain in millions of years. Not because it's too cold, although it is, but because the wind never lets moisture settle. The katabatic winds, fierce and unrelenting, rush down from the ice sheets at over 100 miles per hour, scraping the land clean. They suck the humidity out of the air, out of the soil, out of your skin. Everything here is dry, bitterly dry, and yet there's life, barely. In tiny sheltered spots, between the grains of sand under translucent rocks, inside crusty salt patches, microbial communities survive. They live off trickles of meltwater that come only during the brief Antarctic summer when the sun finally arcs above the horizon and a few stubborn glaciers sweat out thin rivulets of icy runoff. These microbes are among the hardiest life forms on Earth. They endure without light nutrients or warmth for most of the year. Some can even repair their DNA after being shattered by cosmic radiation, the microbial equivalent of coming back from the dead. And to scientists, that makes the dry valleys incredibly exciting. Because if life can exist here in such an extreme, parched, frozen, radiation-bathed place, then maybe it can exist on Mars too. You crouch beside a rock no larger than a lunchbox. From above, it looks unremarkable, maybe even ugly. But beneath it, on its shaded underside, a thin layer of green clings to the stone. Algae. Alive. Dormant, perhaps, but alive. This little patch is known as a hippolyth, a microbial community that lives just beneath translucent rocks, where it's protected from ultraviolet radiation, but still gets just enough light to photosynthesize. It's like life hiding beneath a blanket, waiting for the storm to pass. NASA loves these things. They're not just analogs for Martian life. They might be blueprints for how to find it. If Mars has similar stones, and it does, then perhaps the same trick of survival might exist there too. Maybe, just maybe, if a rover flipped the right rock over, it would find something faintly green clinging to the bottom. Or not green, maybe purple, or red, or something no one's ever seen before. That's the beauty of the dry valleys. They remind you that the limits of life aren't where we thought they were. The dry valleys say, try harder, look closer. Don't assume it's empty just because it's quiet. But the strangeness of this place doesn't stop with life. The geology itself is bizarre. There are ancient lake beds here, vast dry basins where water once pooled long before the Ice Age claimed the continent. Some even contain thick, salty layers of permafrost beneath the surface. And those salt layers, they hold more than just old minerals. They trap gases, bubbles, time. By drilling into these frozen salts, scientists can analyze the trapped gases and reconstruct climate data from hundreds of thousands of years ago. They can tell when the lakes froze, when they dried up, when the air held more carbon or less. The dry valleys are, in a sense, fossil lakes archives of ancient Earth preserved in mineral whispers. Historians still debate whether these valleys were ever warm and wet enough to support real vegetation, mosses, lichens, maybe even flowering plants. Some believe they've always been cold deserts. Others point to pollen grains buried deep in sediment cores as possible evidence of a greener past. But today, there's no grass, no flowers, just sand and rock and wind. And strangely, that's what makes them so valuable, because these valleys are clean. Not in the neat and tidy sense, but in the scientific one. They're uncontaminated, isolated, untouched by industry farming or even most human breath. When scientists study the dry valleys, they're looking at a place that has changed almost nothing in 2 million years. It's like Earth. With the volume turned down, you hike a little further, skirting the base of a low hill. In the distance, a small stream, really more of a trickle, glints in the pale sunlight. You follow it to its source, where a melting glacier lets out a slow sigh of water. Just a few drops, just enough to remind you that even here in the driest place on the iciest continent, water still wins. It may take 1,000 years, but the glacier will move. It may only flow for a few weeks each summer, but the stream will carve a path. And where water flows, life might follow. You dip your fingers into the trickle. It's colder than anything you felt, almost painful, but it's moving, and it's ancient. This meltwater may have been frozen since before humans even learned to speak, before cities, before stories. And now it touches your hand. You rise slowly, casting one last look across the rock-strewn valley. There's nothing here that welcomes you. No shade, no sound, no warmth. But beneath every stone, every frost-bitten ridge, there's a secret. And every secret is the same. This place is not dead. It's just waiting. You stand at the edge of a narrow shaft in the ice, peering down into a pale blue tunnel that stretches far deeper than you can see. The walls shimmer like glass ridged with faint stripes, layers upon layers, like rings in a tree, but colder, sharper. more ancient. This isn't just a hole in the ice, it's a time machine. You're looking into a deep ice core, a vertical column pulled from the heart of the Antarctic ice sheet. Scientists didn't dig this by hand. They used precision drills to bore through thousands of meters of compressed snow and ice, extracting narrow cylinders meter by meter, layer by layer. Each one is labeled sealed frozen and studied because inside those ice cores lies something more precious than gold air from the ancient past. No, really. Tiny bubbles trapped in the ice hold actual samples of Earth's atmosphere going back hundreds of thousands of years. When snow falls in Antarctica, it doesn't melt. It compresses, building up in dense sheets. As it compacts, it traps the air around it, preserving snapshots of the climate, the gases, even the volcanic dust from long-forgotten eruptions. The deepest cores go back 800,000 years. Some scientists believe we could push that to 1.5 million if we find the right spot. That's nearly 1 million years of climate data sealed in frost. It's like reading the diary of the planet, written in whispers of frozen breath. You touch one of the extracted cores, just briefly. The surface fogs with your warmth before frosting over again. Inside that pale rod of ice are clues about when humans first picked up tools, when Neanderthals walked Europe, when mammoths roamed the northern tundra, and Earth remembers it all. But what are scientists actually looking for? They analyze the ratios of gases, mainly carbon dioxide, CO2, methane, CH4, and other trace elements. These tell us how warm or cold the planet was. They can identify sudden shifts, spikes from volcanic eruptions, dips during ice ages, or surges in greenhouse gases during interglacial periods. And when they overlay all that data, patterns emerge. We learn how Earth breathes. There are long, slow cycles of warming and cooling, driven by wobbles in Earth's orbit, axial tilt, and solar output. These Milankovitch cycles, as they're called, shape the timing of ice ages and warm periods. The ice cores confirm this, a steady rhythm of rise and fall, like the pulse of a sleeping giant. But then, something strange happens. You reach the last few inches of the ice core, the newest part, the layers from the last 100 years, and suddenly, the pattern breaks. CO2 levels spike, hard, higher than at any point in the last 800,000 years. Methane jumps too. The planet warms, and it happens fast, not over centuries, but in decades. This is the part where the ice starts whispering louder. It's saying, something's different now. Scientists link the shift to the Industrial Revolution, when humans began burning coal, oil, and gas at massive scales. The ice records this transition with brutal clarity. Before 1800, CO2 levels hover around 280 parts per million ppm. Today, they're over 420 ppm. That's not a subtle change. That's a planetary panic. Historians still debate exactly how much of modern warming is human-driven. But the ice doesn't argue. It simply shows what happened and what's happening now. The data from Antarctica's ice cores have been instrumental in building climate models, complex simulations that predict how Earth's temperature, ocean currents, and weather patterns will respond to rising greenhouse gases. These models aren't based on guesses. They're based on evidence frozen in the continent beneath your feet. And it's not just gases that get trapped. There's dust too. Layers of ash from volcanic eruptions, pollen from ancient forests, even traces of cosmic particles like beryllium-10 that help scientists estimate changes in solar activity. It's all there, a layered library, written in ice. You lean back from the shaft, imagining what it took to extract these cores. The Dome Sea project in East Antarctica took years, drilling nearly 3,200 meters deep. The work had to stop during Antarctic winter when temperatures fell below 880 degrees Celsius. Crews worked in shifts wrapped in so many layers they moved like astronauts. Every meter drilled was a victory, every sample a treasure. And yet, there's so much more to find. New missions are underway to reach older ice deeper still. Scientists are searching for areas where the ice flows slowly enough and has remained undisturbed to preserve air from before the current ice age cycle began. That would be a glimpse into a different Earth, one we've never fully understood. Why does it matter? Because by studying the past, we learn how the Earth responds to change. Natural changes, violent ones, slow ones, and now human ones. If we can see how the planet behaved the last time CO2 levels were high, or the last time the oceans rose, we might understand what's coming next, and maybe how to prepare. You walk away from the core, the wind pressing soft snow against your coat. You don't need a machine to tell you what's changing. You can feel it. The melt, the shift, the planet catching its breath or losing it. Antarctica doesn't scream, it doesn't shout, but it remembers. And the deeper you drill, the more it tells you. The deeper you go into Antarctica, the more it stops pretending to be just frozen wilderness and starts revealing what it really is, a living, heaving, shape-shifting machine. Ice is not passive. It doesn't just sit there waiting to melt. It grows, fractures, collides, and sometimes it explodes. Because beneath this crust of silence, beneath the serene snowfields and blank white valleys, volcanoes are sleeping. And not just the kind you can see like Mount Erebus with its lava lake and fiery plumes. No, the ones we're talking about now are invisible. Hidden volcanoes buried under miles of glacial ice, quietly shaping the very foundation of the continent from below. You're standing above one of them now. No flames, no smoke, just a slight rise in the terrain, a bulge in the ice subtle enough to miss unless you're looking. But beneath that rise, heat, pressure, magma, waiting. These are Antarctica's subglacial volcanoes, and they might number in the hundreds. In fact, one survey conducted by researchers from Edinburgh in 2017 identified 91 potentially active volcanoes buried beneath the West Antarctic ice sheet alone, the largest concentration of volcanic activity in the world that almost nobody talks about. Why? Because they're hard to find. No one's hiking around with a stick looking for lava pits. Instead, scientists use satellite imagery, radar gravity measurements, and something called aeromagnetic surveys to detect the hidden giants. Think of it like trying to read Braille with a drone. And once they started looking, the pattern was unmistakable. The West Antarctic Rift System, a vast region where the Earth's crust is stretched and thinned, is dotted with volcanic peaks buried under glacial cover. Some are dormant, some may be extinct, but a few are still hot. Very hot. You kneel in the snow and press your hand against the ground. Of course it feels freezing, but if you had the right instruments, a thermal sensor, say, you might detect anomalies. Pockets where the temperature rises faster than it should, where the ice is thinning, not from above, but from below. And this matters a lot, because when a volcano heats the base of a glacier, it melts the ice in ways that are both invisible and dangerous. It creates lubricating layers of meltwater that allow the overlying ice to flow faster. That means glacial acceleration, ice shelf instability, and potentially catastrophic collapse. One such area is Marie Byrd Land, a remote part of West Antarctica, where radar studies have detected both elevated geothermal heat and active volcanic plumbing systems beneath the ice. Think of it like a frozen lid over a simmering stew. You may not see it boil, but pressure is building. And it's not just slow heating. Some of these subglacial volcanoes erupted during the last few thousand years. Evidence of past eruptions is preserved in layers of tephra volcanic ash embedded in the ice cores. These eruptions didn't create firestorms or rivers of lava, but they did send heat upward through the glaciers, possibly triggering shifts in ice dynamics that we're still trying to understand. Historians still debate how much volcanic activity contributes to Antarctic ice melt. Some argue that geothermal heat is a localized factor, significant, but minor, compared to atmospheric and oceanic warming. Others point to regions where ice loss aligns suspiciously well with geothermal anomalies, suggesting that volcanoes might be playing a bigger role than we thought. You stand now looking across a field of unbroken ice. A low mist clings to the horizon, and the only sound is the wind. There's nothing to suggest you're standing atop a network of magma chambers and lava tubes, but you are. And it's humming. Not all volcanoes erupt with violence. Some simply heat the world around them steadily, patiently. And in a place like Antarctica, where everything is balanced so precariously that heat can change everything, you walk forward, and the ground beneath you dips gently. Scientists believe some subglacial volcanoes have carved entire valleys beneath the ice, called volcano-induced subglacial basins, where lakes now form hidden from view. These lakes are warm enough to remain liquid, but cut off from the atmosphere. And where there's liquid water, there might be life. Yes, life again. Because where heat and water meet, even under pressure, even in darkness, biology often finds a way. It's entirely possible that microbial ecosystems exist beneath the ice, thriving off geothermal heat from these volcanoes. They would be chemotrophic, feeding on chemicals instead of sunlight. Just like the life forms found near hydrothermal vents deep in Earth's oceans. Just like the life we might find on Europa or Enceladus, the icy moons with hidden oceans and geothermal activity. So in a strange twist, these buried Antarctic volcanoes may offer clues not just to Earth's geology, but to the search for extraterrestrial life. Of course, volcanoes are temperamental. If one of them were to erupt with enough force, it could destabilize large portions of the ice sheet, rapidly melting ice, creating new drainage paths, even altering sea levels. But eruptions under all that ice wouldn't look like the ones you know. No plumes, no fire, just sudden movement, cracks in the surface lakes, draining unexpectedly, glaciers surging without warning. Imagine waking up to find that 1,000 square mile section of ice has shifted overnight, not from storms, but from heat rising in the dark. You wouldn't even hear it, but the satellites would, and they'd know something deep just stirred. You pause, listening. The wind is high, and the clouds roll low. There's no tremor, no heat, no light. But still, you know what's under you now. You know the secret. Beneath all this silence and snow, Antarctica burns. There's a myth in your head, something you've believed since childhood, that Antarctica is and always has been a land of nothing but ice, white, barren, frozen, sterile. But then the wind shifts. You see a strange shape protruding from a rock face, blackened, fibrous, curved like the ghost of a tree. And that myth begins to crack, because Antarctica once had forests, not little patches of moss, not a couple of lonely shrubs clinging to cracks in the stone. No real forests, towering trees, wide river valleys, thriving ecosystems, a green world teeming with life. And beneath the miles of ice that now blanket the continent, the fossils of that world still remain. You reach the edge of a jagged outcrop, one of the few places where rock breaks through the ice. Here, scientists have discovered fossilized wood leaves and even the delicate imprints of ferns. Some finds are so well preserved you can still see the veins in the leaves, not scorched or burned, not crushed to ash, just paused, suspended, like someone pressed them into the earth and gently closed the freezer door. These remains date back 90 million years to the mid-Cretaceous period when Antarctica was part of the supercontinent Gondwana. Back then, it sat farther north, yes, but not by much. And yet the climate was subtropical, warm, humid, and fertile. It's a strange image, isn't it? The same land you're standing on now, blasted by blizzards and cloaked in endless ice, was once home to conifer trees, ginkgo forests, and even flowering plants. Picture this place with rivers buzzing insects and perhaps the occasional dinosaur wandering through the undergrowth. And then the world shifted, continents drifted, ocean currents changed, CO2 levels dropped, and Antarctica began its long, slow freeze. It didn't happen overnight. At first, the winters grew harsher. Trees still clung to life, their rings recording the stress of changing seasons. Eventually, only cold-tolerant species survived. Then came the glaciers, then the ice sheets, and then silence. Historians still debate how long it took for the transformation to be complete. Some say Antarctica had patches of forest even as recently as 40 million years ago. Others argue it was locked in ice far earlier. What's clear is the land didn't forget. It preserved the evidence. Fossil forests have been discovered on Seymour Island, transantarctic mountains, and parts of the Antarctic Peninsula. In one place, scientists even found tree stumps still rooted in position standing upright in sediment. That's right, not fallen, not scattered, still standing as if waiting for sunlight that never came. You kneel beside one of the fossilized logs, brushing away windblown snow. It's not quite wood anymore. The organic material has been replaced by minerals over time. But the grain is still there. The rings, the structure. You could run your fingers over it and feel the tree's final years, each ring a whisper from a world long vanished. And there's more. Microscopic studies of these fossils have revealed fossilized spores and pollen-tiny particles that help reconstruct the plant life and ecosystems of ancient Antarctica. These records show diverse forests, including evergreens, ferns, and even palms in some regions. Yes, palm trees in Antarctica. You shake your head trying to make sense of it. But that's the point. Antarctica isn't a blank slate. It's a palimpsest, a parchment that's been scraped clean and overwritten by ice, but still carries the faded script of an earlier story underneath, one that still matters, because the past climate conditions that supported those forests, they're not just curiosities, they're warnings. Scientists study these ancient warm periods, especially the Cretaceous and Eocene epochs, to understand how Earth behaves under high greenhouse gas concentrations. Back then, CO2 levels were likely well over 1,000 ppm, more than twice today's levels. And Antarctica responded with warmth rainfall and jungle-like vegetation. Today, our CO2 levels are rising faster than at any point in geological history. and the ice is retreating again, slowly for now. But if the trend continues, what comes next? Could Antarctica one day turn green again? Some models suggest it's possible. Not in decades or even centuries, but eventually. If all the ice melts, the continent beneath will be exposed. The Antarctic bedrock surprisingly includes valleys, mountain ranges, and wide flat basins, fertile ground for whatever plants could reclaim it. It sounds like science fiction, but it's grounded in the rock you're touching right now. You rise looking across the desolate snowfield. There's no sign of life here now. No trees, no chirping birds, just wind and white. But in your mind, the image lingers, a canopy of ferns, rustling in warm breezes, dinosaurs stepping cautiously between trunks, flowers blooming where today only ice endures. It's easy to think of Antarctica as dead, but beneath the surface, it's simply asleep. And if the past tells us anything, it's this: nothing stays frozen forever. The wind is picking up again, cold and sharp across the flat sheet of snow. But something else rides on it now. A whisper of footsteps, boots against ice, canvas tents snapping in the wind, the low groan of wooden hulls twisting in the cold. You're not alone out here. You've entered the long shadow of Ernest Shackleton and his most famous expedition, one of the greatest survival stories ever told. A tale of courage, miscalculation, endurance, and ice. It begins in 1914, just as the world descends into the chaos of World War I. Shackleton, a seasoned polar explorer and something of a national hero, has a plan. He wants to become the first person to cross the Antarctic continent from sea to sea via the South Pole, a 800-mile trek across the most brutal terrain on Earth. The ship he selects for this mad journey is named Endurance. Fitting. She's a wooden, three-masted barquentine, state-of-the-art for her time, but still very much a ship of wood rope and hope. With a crew of 28 men, including scientists, carpenters, a photographer, and even a stowaway Endurance, departs for the Weddell Sea. The goal is to land on the coast of the continent, march across the ice, and emerge on the other side. They never make it. Just one day's sail from their landing point, the Endurance becomes trapped in thick pack ice. The men wait. They hope for a thaw, but Antarctica doesn't care about hope. The ice clamps tighter, crushing the ship inch by inch. The wood groans. The hull splinters. Over months, it becomes clear the ship is going to die. And then one day, she does. On October 27th, 1915, the Endurance is finally crushed and sinks, leaving the crew stranded on drifting sea ice, hundreds of miles from land, with limited supplies, no communication, and the realization that no rescue is coming. You stand now on that same ice flat, infinite and quiet, and you try to imagine what they felt. The cold, the hunger, the waiting. They built shelters from salvaged wood. They hunted seals. They played football on the ice to stay sane. They watched the sun vanish for winter and did their best not to go mad in the endless dark. Historians still debate whether Shackleton made the right calls. Some say he underestimated the risks. Others praise his leadership. But what no one argues is this: he kept every one of his men alive. Eventually, with supplies running low, Shackleton makes a bold move. He takes 5 of his strongest men and sails 800 miles in a tiny open boat, the James Caird, across the roughest ocean on Earth, the Southern Ocean, aiming for a whaling station on South Georgia Island. The voyage is legendary. 20-foot waves, freezing spray, navigation by stars. When they finally reach land, they're on the wrong side of the island, facing a mountain range no one has ever crossed. So they do it anyway, with no climbing gear, no maps, no rest. When Shackleton finally staggers into the whaling station, emaciated and wild-eyed, the station manager reportedly weeps, but Shackleton doesn't stop to celebrate. He immediately organizes a rescue mission. It takes 4 attempts and 4 more months, but he eventually returns to his men, every single one still alive, waiting patiently on Elephant Island, believing somehow that their leader would return. And he did. You walk a few steps across the ice and come to a strange stillness, a memory caught in the cold. Shackleton's story is more than an adventure. It's a reminder that the human spirit can endure even here at the end of the earth. But the ice never forgets. In 2022, more than a century after the Endurance sank, a team of researchers located her wreck perfectly preserved on the seafloor, over 3,000 meters deep. Not torn apart, not rotted intact, her name still visible on the stern. She had waited patiently, like the continent itself, for someone to find her. And now that they have, we're learning from her again about materials, navigation, leadership, survival, about what it takes to stand against the cold. You crouch and run your hand across the surface of the snow. It doesn't feel different from the rest, but now you know what's buried beneath. Not just wooden planks and sails, but a legacy, a testament to what people will risk in the name of discovery, and what they'll sacrifice to get each other home. Because Antarctica doesn't give second chances. But Shackleton, he made one happen. Some nights, they say when the wind is right and the stars are low, you can almost hear the creak of sails and the crunch of boots. The ghosts of endurance still walk these frozen paths, quiet, proud, and very much alive. And you walk with them now. You pause, ears open to the wind, expecting silence. Instead, you hear something else, a faint tone, not mechanical, not natural, almost like a hum. It pulses low, rhythmic, then gone. You hold your breath. There it is again. You're not imagining it, because down here in the belly of Antarctica, even the ice talks. Scientists call them infrasound signals, low-frequency vibrations that ripple through the ground and air below the threshold of human hearing. But just because you can't hear them doesn't mean they're not happening. Antarctica hums all the time. And lately, it's been sending out signals we still can't explain. Some come from deep glacial creeks, the thunderous groaning of ice moving over rock. Others originate from sudden shifts in pressure as frozen lakes drain beneath the surface. But then, there are the weird ones. The ones that seem to repeat. The ones that sound organized. In 2020, researchers recorded a mysterious seismic pulse coming from within the ice shelf, not once, but on a fixed 13-hour cycle. They checked everything: tides, temperature, satellite positions. Nothing matched. The pulse was consistent, like a heartbeat. Every 13 hours. Faint, mechanical, real. Some thought it might be an internal echo of the ice's own flexing, or the pressure buildup in a buried subglacial lake. Others joked about alien drills, quietly. After the microphones were off, you shuffle forward, boots crunching snow, and recall another signal, this one underwater. Back in the 1990s, hydrophones placed in the Southern Ocean picked up what has become one of the world's most famous unexplained sounds. It was deep, loud, traveling across thousands of kilometers. It was called the bloop, and no one knows exactly what it was. The frequency resembled that of a biological origin, an animal maybe. but no known creature is big enough to create a sound like that. Some scientists believe it was ice calving or a massive underwater quake, but others aren't so sure. To this day, there's no definitive answer. The bloop came from somewhere near Antarctica, and it's not the only one. There's also Julia slowdown and train oddly named signals captured over the last few decades, many originating near the continent. Some have been chalked up to shifting sea ice or interactions between deep water layers, but others still up for debate. You might ask, so what? A few weird noises in the middle of nowhere, but Antarctica is full of signals like this. Not just seismic or acoustic, electromagnetic anomalies too. Tiny fluctuations in magnetic fields, unexplained blips on radar, brief interruptions in satellite telemetry when flying over specific regions. Scientists explain most of them solar flares, static mechanical error, but not all. Take Lake Vostok, for example. When researchers first started mapping the subglacial lake using radar, they noticed odd reflections, bright spots, and straight lines unusual for a natural lake. Some thought it could be from internal layering in the ice. Others, they weren't so sure. The lines were too geometric, too regular. Conspiracy theorists had a field day. They claimed the signals were evidence of buried structures, alien bases, or ancient civilizations sealed in ice. One theory suggested the Nazis had discovered something under the ice during their mysterious 1938 Antarctic expedition and vanished beneath it. Another insisted there were heat signatures too warm to be natural proof of secret installations. You don't buy most of it. But standing here now, in this desolate expanse of frozen nothing, you understand why people let their imaginations wander. When everything is hidden, everything is possible. And you haven't even heard about the hum. In some parts of Antarctica, scientists working near long-term research stations report a persistent low-frequency vibration in the environment. Not always audible, more of a feeling than a sound. Like standing next to a large engine you can't see. Some call it the Antarctic hum. There are theories, of course. Glacial grinding, airflow through complex rock formations, the resonance of the ice sheet itself. But the hum never quite lines up with any one cause. It's always there, or almost always, like a voice that doesn't need words. Historians still debate whether these kinds of natural signals played a role in early myths about the South Polar lands, legends of ancient beasts beneath the ice, or entrances to inner Earth realms. Were early explorers simply interpreting the strange rumblings and cracks as something more? Or is that just what we tell ourselves to feel better? You stop walking and take out a small field recorder, hypothetical of course, and press record. Nothing. Static. Wind. Then faintly the ice pops. It's not an earthquake. Not even a tremor. Just a single snap, like bones shifting in the Earth's skeleton. You stare out into the distance and try to imagine the hidden networks of sensors scattered across the continent, seismic arrays, magnetic sensors, hydrophones beneath the ice, all listening to the whispers of a world that's never been silent. If Antarctica is alive, and by now you're starting to believe it is, then these signals are its language, its way of expressing change pain memory. Ice doesn't speak in syllables. It speaks in tremors and tones, in echoes and vibrations that pass unnoticed until someone stops to listen. And tonight, that someone is you. You take one last moment in the eerie quiet, standing still, listening to what the continent might be trying to say. A low, slow hum. A heartbeat in the snow. a frequency just outside your reach. It's not just ice, it's signal, and it never truly stops. The wind is still humming low across the ice. But now, there's something else hanging in the air. Not sound exactly, but suspicion. A sense of being watched, a twitch in your gut. You've spent enough time out here to know that Antarctica doesn't just test your body. It tests your mind, which is probably why for decades, the frozen continent has been a magnet for conspiracy theories. Some of them are harmless, entertaining even. Others, wild, deep, often unprovable. And somehow, they all begin with the same premise. What if Antarctica isn't what we've been told? Let's start with one of the oldest and most persistent, the Nazi base myth. In 1938, just before World War II broke out, Nazi Germany launched a real expedition to Antarctica. They called it Neuschwabenland. They sent a ship, a crew of scientists and military personnel, and a fleet of aircraft. Their stated goal: claiming new whaling territory and establishing a German presence near the South Pole. They dropped aluminum darts marked with swastikas to mark territory. They took thousands of aerial photographs. Then they left, or so the official record says. But according to conspiracy theorists, they never really left. Instead, they established a secret base deep within Antarctica, possibly inside a hollowed-out mountain or beneath the ice. Some stories claim the base, dubbed Base 211, became a hidden Nazi stronghold where scientists continued their experiments long after the war ended. Some even suggest that high-ranking officials fled there, escaping the fall of Berlin in 1945 and disappearing into the ice. Do we have any evidence? Nope, none. But that hasn't stopped the theory from spreading. Over the years, it's become tangled with other wild ideas that the Nazis discovered alien technology under the ice, that they reverse-engineered flying saucers, that UFO sightings in the 1950s were actually tests of this frozen technology. Which brings us to the next myth, the Hollow Earth theory. According to this one, Antarctica isn't just a continent. It's a gateway. A massive hole near the South Pole leads not to bedrock, but to the interior of a hollow Earth. A world within our world, warmed by a central sun and possibly inhabited by advanced civilizations. Some say the Nazis found the entrance. Others say the US government did. They often cite Operation High Jump, a real US Navy mission from 1946, led by Rear Admiral Richard Byrd. The operation was massive, 13 ships, over 4,000 men, aircraft, and equipment. Officially, it was meant to test military readiness in polar conditions. But the timing, right after WW2, and the scale of the mission sparked rumors. Why send such a huge force to Antarctica, if not for something secret? Admiral Byrd himself added fuel to the fire. In interviews, he mentioned flying beyond the South Pole and seeing a land of green meadows, forests, and rivers. Critics say he was describing Arctic flights, or that his words were misquoted. Believers, they say he found the entrance and that his discovery was buried by the government. Then there's the pyramids. Yes, pyramids. Satellite images of Antarctica have revealed mountain peaks with strange symmetrical shapes, triangular structures that some say resemble ancient pyramids. Theorists believe they're not natural, that they were built by an ancient lost civilization before the ice came. A civilization that may have predated Egypt, or never been human at all. Geologists, of course, have a more grounded explanation. They're nunataks, peaks of rock that protrude through the ice. Erosion, wind, and time gave them sharp pyramidal shapes. But from the right angle, with a little imagination and a blurry screenshot, they look suspiciously precise. And if that's not enough, there's Lake Vostok, the subglacial lake we visited earlier. Some theorists claim that beneath its surface lies not just microbial life, but a buried structure. They point to radar anomalies, long straight lines, bright reflections, and magnetic irregularities as possible proof of something artificial beneath the ice. Some even claim extraterrestrial origins, which sounds absurd, until you realize how little we actually know about what's under the ice. Most of Antarctica is completely unexplored. The sheer size of it, the depth of the ice, the isolation, the inaccessibility leaves just enough room for imagination to bloom like frost on a window. Historians still debate the psychological allure of these theories. Maybe it's because Antarctica is so quiet, so unknowable. Humans hate a vacuum. When faced with the great blank spaces of the map, we tend to fill them with monsters. In the past, it was sea serpents and lost continents. Today, secret labs, lost civilizations, and alien beacons beneath the snow. But here's the twist. Just because the conspiracy theories go too far doesn't mean there aren't real mysteries down here. Antarctica does hide entire mountain ranges, subglacial lakes, fossilized forests, ancient air bubbles that rewrite what we know about Earth's past, even strange seismic signals we still don't fully understand. You don't need aliens or Nazis and flying saucers to make this continent fascinating. The truth is weird enough. Still, as you scan the icy horizon, a part of you wonders, what haven't we found yet? What lies just 100 feet deeper than the deepest core? What's hiding in the warm water beneath the oldest glacier? And why do so many people, even with no real proof, believe that Antarctica knows more than it's telling? The wind shifts again. You tighten your hood and start walking, not toward a secret base, not toward a hidden hatch or a buried ship, just deeper into the snow. But now, you're listening a little harder and watching the shadows a little more closely. Because even if the wildest theories aren't true, they were born from something. And Antarctica, quiet as it is, has never stopped whispering. The wind howls across the frozen plain, but something about its pitch has changed. It's higher, sharper, a little too steady, almost mechanical. That hum in the distance, it's not the wind anymore. You've reached the edge of a massive camp of canvas and steel long since packed away. Only traces remain. Now sun-bleached ropes half buried in snow-rusted fuel drums, poking out like bones, and a few scattered planks flattened into the permafrost like pressed leaves in a glacial book. This was once the launch pad for Operation High Jump, one of the largest, most secretive, and most misunderstood expeditions in Antarctic history. It began in 1946, just after World War II. The United States Navy sent a fleet of 13 ships, 33 aircraft, and over 4,700 men to the frozen continent. Officially, the purpose was to test military operations in cold conditions and to establish American presence in Antarctica. Unofficially, well, that's where things get slippery, because High Jump didn't behave like a typical research mission. It was militarized, equipped with destroyers, aircraft carriers, and submarines. It had cryptic orders. And after just a few months, well short of the planned duration, the mission was suddenly cut short and the fleet withdrawn. No clear explanation. Naturally, the silence fueled theories. Some whispered of hidden German installations left behind from the war. Others said Admiral Richard Byrd, the mission's leader, had encountered something so dangerous that he ordered a hasty retreat. In one alleged interview with a Chilean newspaper, Byrd warned that the U.S. should prepare to defend itself from enemies that could fly pole to pole at incredible speeds. Theorists jumped on it. UFOs, anti-gravity craft, interdimensional portals. And just like that, Operation High Jump became more than a military drill. It became legend. But let's strip away the fog and look at what really happened. The expedition did conduct extensive mapping. Over 70,000 aerial photographs were taken, much of which remains useful to glaciologists even now. They tested equipment, set up temporary weather stations, and they experienced extreme hardship, howling gales, whiteout conditions, equipment failure, and yes, loss of life. One plane, a Martin PBM Mariner, crashed in the interior during a blizzard. 3 crewmen died. The survivors endured for 13 days on the ice, surrounded by wreckage, huddling in makeshift shelters made from parachutes and engine parts before rescue arrived. Those who've studied the operation in detail argue that it was indeed what the Navy claimed, a military cold weather training mission, nothing more. And yet, the secrecy around the mission's early termination remains suspiciously thick. Even declassified documents raise eyebrows with their redactions and missing pages. Byrd himself became increasingly tight-lipped about the expedition later in life. He passed away in 1957, leaving behind notebooks that some believe still haven't been released in full. Historians still debate what the mission may have uncovered. Some suggest it encountered unstable ice or unexpected magnetic anomalies. Others claim the Navy may have found geothermal activity beneath the ice that could explain unusual signals and heat signatures. And then there are the wildest claims that Byrd's aircraft entered a hole in the earth, flew over a lush interior world, and encountered advanced beings. This myth forms the basis for some modern Hollow Earth beliefs, and despite being thoroughly debunked by mainstream science, it still thrives on forums and in conspiracy corners of the web. You walk along the ghost of a runway, now flat-etched with wind-scoured ridges. The ice here feels strange, denser, like it remembers the weight of those long-gone planes. And suddenly you can see it, the aircraft lifting into the icy sky, cameras rattling in their mounts, crew bundled in wool and leather. Below them, a terrain no human had seen before. Mountain ranges wrapped in mist, gaping crevasses plunging into blackness, smooth ridges too symmetrical to ignore. What did they see out there? What did the photographs show? You'll never know. Many of the aerial images were classified for decades. Some still are. Those that have been released often feel incomplete frames, missing angles, cut awkwardly short. Did they capture ancient structures beneath the ice, massive subsurface lakes with unnatural geometry? Or perhaps nothing unusual at all? Just the illusion of design in a land so empty that the mind fills in its own stories. Even without conspiracies, Operation High Jump was a monumental undertaking. It stretched human endurance. It mapped parts of the continent no one had ever touched. And it revealed the logistical nightmare of working in a place that does not want you here. But the timing matters too. Just a few years later, in 1959, the Antarctic Treaty was signed. Countries around the world agreed to preserve Antarctica for peaceful scientific exploration, banning military activity, weapons testing, and resource extraction. Some argue that this was a political necessity, a response to Cold War tensions. Others think it was a cover-away to lock the door on secrets already discovered. You stand now in the center of the wind-beaten clearing, surrounded by ghosts. Somewhere in the back of your mind, you imagine Byrd himself standing beside you. Goggles, frosted his gloved hands, tracing a line across a frozen map. What did you really see out there, you want to ask him, but the silence answers for him. The operation ended. The records were filed away. The snow returned. And whatever was found, if anything was found, is now hidden beneath decades of frost and half-truths. Still, the ice remembers. It always does. And whether Operation High Jump was an elaborate training mission or something far stranger, it left behind a lingering echo, a crack in the silence, one that still hasn't closed. The ice stretches out around you, blank and blinding, but there's a tremble beneath it now. Not quite a sound, more like a feeling. A hush that deepens. A cold that sinks lower than before. You're not above the ice anymore. You're beneath it. You slip into one of Antarctica's most elusive features. The ice caves and crevasses, narrow corridors of blue silence that tunnel through the continent like veins beneath skin. Some of these caverns are natural, formed by the slow melt of glacial ice, while others are hollowed by winds, pressure, or ancient eruptions. But all of them share one thing in common: they're hidden, and they don't like to be found. In the last decade, scientists have begun to probe these hidden passages, dropping drones and remote sensors into cracks just wide enough for a camera. What they've found defies expectation. Beneath Antarctica's glaciers are not just cracks and voids, but entire subglacial cave systems complete with flowing water heat and sometimes strange shapes. You descend carefully now, one hand trailing the wall of ice beside you. The light refracts in 100 directions. Soft blues, translucent whites, thin ribbons of trapped air stretching like old scars across the frozen walls. Water drips in perfect silence. The deeper you go, the more the light fades until you're moving through a world of slow sound and shifting shadow. And then you feel it, a warm draft of air. It makes no sense. Outside, it's 40 degrees. But down here, the temperature rises just a little, enough to fog your breath. Welcome to one of Antarctica's thermal ice cave systems, warmed not by surface sun, but by volcanic heat far below. Mount Erebus, for instance, isn't just a surface volcano. Its geothermal energy radiates outward, melting ice and forming hollow tubes and caverns beneath the glacier above. Some of these caves are tall enough to stand in, others just wide enough for a robotic probe. And what the probes see inside is strange. Lava tubes under Erebus contain mineral deposits, unusual patterns on the walls, and sometimes microbial life, tiny organisms surviving in total darkness, feeding off sulfur and heat. Scientists speculate that these microbes may have adapted independently, isolated from the surface for thousands, perhaps tens of thousands of years. That's fascinating enough, but then there are the shapes. Not alien structures, not UFO bases, but formations, perfectly circular tunnels, geometric ridges, smooth walls that don't quite match the chaos of natural erosion. Some scientists chalk this up to consistent heat flow and the way ice melts under pressure. Others aren't so sure. Radar imaging of some ice caverns beneath Antarctica has revealed massive voids, some large enough to contain entire skyscrapers. One such cavity was discovered beneath the Thwaites Glacier, nearly 1,000 feet tall, stretching for miles. It had never been seen before. It shouldn't have been there, and it's growing. That's the terrifying part. The void beneath Thwaites isn't just a gap in the ice. It's evidence of rapid melting happening faster than any model had predicted. It suggests that parts of the glacier are hollowing out from the inside, the bottom falling away, the ceiling collapsing slowly from below. Historians still debate whether similar processes contributed to previous collapses during past warm periods. But no historical ice record includes voids this large forming this quickly. You pause, deep in the cavern now. Your light flickers along the walls, catching a reflection that's too straight, too clean. It's just a piece of melting ice, but for a moment, it looks like a door. Your mind drifts, not just into science, but into myth. Ancient explorers believed Antarctica held secrets beneath the surface. Theories of hollow Earth, of buried civilizations, of lost cities sealed in ice. For years, people spoke of hidden entrances, gaping caves that reached miles into the continent's heart. The kind of passages that led not into ice, but into a different world entirely. Even the military took notice. Declassified documents show that certain regions of Antarctica, particularly those with unusual cave networks or magnetic anomalies, were surveyed extensively during the Cold War, not just for science, but for strategic interest. Some files remain sealed. Could these cave systems connect to one another beneath the continent? Could there be a network of subglacial corridors warm enough, vast enough for something larger than microbes? Geologically, it's possible. The land beneath Antarctica is riddled with fault lines, geothermal hotspots, and rivers of meltwater. Combine that with volcanic heating, and you get the potential for caves stretching dozens, maybe hundreds of kilometers beneath the ice. No human has explored them in person yet, but autonomous underwater vehicles, sleek torpedo-like drones, are being tested now to map these under-ice caverns in real time. They navigate blind, guided only by sonar and instinct. If one ever gets lost in a tunnel, too deep to surface, too narrow to turn, it simply becomes part of the mystery, and so do its recordings. You shine your light farther ahead. The tunnel curves slightly, then splits. One path leads deeper down toward heat. The other narrows, cracking into what looks like a wall of crystal. Your breath fogs the beam of your flashlight, and then again, warmth. This place shouldn't exist. Not here, not now. And yet, it does. That's Antarctica. What seems dead isn't. What seems solid shifts. What seems too cold to harbor life harbors entire worlds tucked away in silence beneath glaciers that watch you with blank, ancient faces. You turn back slowly. The tunnel seals behind you in shadow, but the ice cave remembers your presence, just like it remembers everything else. The sky above is gray, now darker than it should be at midday. A low ceiling of clouds stretches over the ice like a thick wool blanket, dimming the light to a sleepy twilight. The wind has calmed, but something else stirs the air, a metallic tang, faint but unmistakable. The scent of iron. You follow the trail of scattered red specks in the snow, at first thinking maybe they're stones, or perhaps rust. But no, they're liquid, frozen but once flowing. Red. You've reached Blood Falls. It sounds like a horror story, and in a way it is, but not the screaming haunted kind. This is the kind of horror that creeps in slowly, ancient and quiet, and utterly real. Blood Falls is one of Antarctica's strangest and most visually shocking features, a gash in the Taylor Glacier, where bright red water oozes out of the ice like an open wound. No joke. It looks exactly like blood pouring from the mouth of a glacier, and for nearly a century no one knew why. When explorers first stumbled across it in the early 1900s, they thought the red color came from algae. It was the obvious guess. But tests found no such thing. The red wasn't biological, it was chemical. The real answer lay deep beneath the glacier, in a world no one had seen, in millions of years. You step closer to the stained ice and stare into the frozen spill. It's not bright cherry red like a movie prop. It's darker rust-colored like dried blood or old iron. Because that's exactly what it is. Blood Falls is made of iron-rich brine saltwater, laced with iron from a hidden subglacial reservoir beneath the glacier. As the iron-rich water flows out and hits oxygen for the first time in eons, it oxidizes, turning a deep, vivid red, like a metal blade left too long in the rain. But the color isn't the most shocking part. The real mystery is the source, a hidden subglacial lake, sealed beneath nearly 400 meters of ice. No sunlight, no oxygen, no fresh nutrients, and yet, something is alive down there. In recent years, scientists drilled carefully into the ice above Blood Falls and discovered extremophile microbes living in the brine, microorganisms that had survived for more than 1 million years in total isolation. They feed not on sunlight like most life on Earth, but on sulfur and iron, using chemical reactions to stay alive in total darkness and crushing cold. No photosynthesis, no oxygen, just iron, sulfur, and salt. And they've been doing it for millennia. These microbes may be the oldest isolated ecosystem ever discovered. A pocket of prehistory preserved in ice, untouched by modern Earth. They are time capsules with tiny flagella, and they are rewriting what we thought we knew about the limits of life. Historians still debate whether these conditions mirror those found on other celestial bodies. But astrobiologists are already paying attention, because what survives in Blood Falls might also survive on Europa, the icy moon of Jupiter, or beneath the surface of Mars, where briny liquid water may still lurk in buried aquifers. In that sense, Blood Falls isn't just strange. It's a preview of what alien life might look like. You crouch by the edge of the glacier, watching the rust-colored trickle ooze from the ice. It's not fast, not dramatic. It's slow, relentless, a wound that never quite heals. The name Blood Falls wasn't chosen to be poetic. It's accurate. It captures the unsettling sense of something ancient and hidden finally finding its way to the surface. A buried thing that refuses to stay buried, and the flow never stops. Even in the bitter cold, the brine remains liquid because it's 5 times saltier than seawater. That extreme salinity lowers its freezing point, allowing it to move through narrow veins and channels deep within the glacier. Scientists believe the underground lake that feeds Blood Falls is slowly draining through a network of subglacial fissures, pushed by pressure rather than gravity. It's a slow-motion exhale, a glacial sigh that's been building for 1 million years. You stand now where that sigh breaks the surface. The red stain creeps outward like a smear of war paint on an otherwise pristine glacier. It's beautiful and just a little horrifying, because it reminds you the ice is not empty. It's not sterile. It's not clean. It's alive in ways that have nothing to do with penguins or whales or fluffy snow. It's alive in brine and bacteria and chemical exchanges that echo across geological time. It holds the fingerprints of climates long gone, of microbes that never saw the sun, of stories that never made it to the surface until now. And there may be more. Blood Falls isn't the only subglacial anomaly. Across Antarctica, researchers are discovering strange discolorations, unusual thermal signatures, and chemical plumes rising from beneath the ice. Each one could point to another hidden ecosystem, another sealed lake, another version of Blood Falls waiting to open. Some believe we've only scratched the surface, that the real secrets lie deeper in lakes like Mercer Willans and even Lake Vostok, which may harbor more complex organisms, possibly worms, crustaceans, or entire microbial food chains. But for now, Blood Falls remains the most visible, most striking example of what happens when the deep past leaks into the present. You step back, your boots crunching softly on the frost-bitten ground. The red water continues its crawl, inching over snow that will eventually absorb it, bury it again, and forget it ever surfaced. But you won't forget, because you've seen it now. And it's not just the color that stays with you. It's the feeling that under all this white, something ancient is still bleeding. You've seen penguins huddle against the cold. You've seen blood seep from the ice like a silent scream. You've felt the breath of volcanoes sleeping beneath your boots. But now you're going smaller, much smaller. Because the most resilient survivors in Antarctica aren't whales or birds or seals. They're microbes, and they're everywhere, in frozen lakes, in salty brine, in solid ice, even in rocks. These aren't ordinary microbes either. These are extremophiles organisms that thrive where almost nothing else can. Their motto isn't adapt or die. It's adapt and laugh in the face of death. You're kneeling now beside a core sample recently pulled from an ancient ice layer. Under the microscope, the ice looks like cracked glass lined with tiny filaments. Inside, microbes, frozen for thousands of years, maybe even millions, and yet, in some cases, still alive. Let that sink in. Something buried in darkness, frozen solid, without oxygen, without light, and somehow it survived. In 2009, scientists revived microbes from Lake Vostok, trapped beneath 4 kilometers of ice for millions of years. When thawed carefully in a sterile lab, the cells stirred, fed, multiplied. They weren't dead, just waiting. In 2013, researchers drilled into Lake Willans, another subglacial body of water, and found entire microbial ecosystems living in total darkness, processing minerals and nutrients released by the bedrock beneath the ice. These communities are independent of the sun. Their entire energy cycle comes from geochemistry, not photosynthesis. That's the real stunner here. They don't need sunlight. They don't need oxygen. Some don't even need warmth. They survive by breathing iron, or reducing sulfur, or oxidizing hydrogen. It's like they've rewritten the rules of biology. Or maybe we just never knew the rules to begin with, and that opens a door. Because if life can survive in Antarctica's hidden pockets, sealed away, pressured frozen, then life might exist in similar environments elsewhere in the solar system. Europa, Enceladus, Mars, maybe even places we haven't dreamed of yet. Astrobiologists now study Antarctic microbes not just for their weirdness, but as models for alien life. They isolate enzymes that function at 30 degrees CC. They sequence DNA that's barely changed in 1,000,000 years. They study membranes that stay flexible when most cells would shatter, and the secrets keep coming. In some cases, microbes appear to go beyond dormancy. They don't just pause. They enter a kind of suspended animation, a biochemical coma so deep that their metabolism nearly halts. But given the right temperature, moisture, and pressure, they wake up. Historians still debate whether such conditions could exist on ancient Mars. But here in Antarctica, they exist now. You press your gloved finger to the ice wall of a borehole. Inside, under layers of compacted snow and pressurized frost, there are organisms older than human civilization. If they could talk, what would they say? Probably, we've been through worse. Some microbes here survive ultraviolet radiation, dehydration, and cosmic rays. They're buried deep enough to escape most surface threats, but when exposed, they fight back with biochemical shields, antioxidant defenses, and efficient DNA repair mechanisms. And they're not all bacteria. Scientists have found archaea fungi, and even signs of microscopic eukaryotes, more complex organisms with nuclei and internal structures. There's even speculation that tiny tardigrades, the infamous water bears, may be hiding somewhere in Antarctica's subglacial world. Hardy little creatures that can survive the vacuum of space, boil, freeze, and come back for breakfast. You know what's funny? All of this life, and most of it, is still undiscovered. We've only drilled into a tiny fraction of Antarctica's hidden lakes, caves, and melt zones. Each expedition brings new species, new genetic sequences, new ways of surviving. It's like a biological time machine, a frozen zoo of Earth's evolutionary creativity, and some of it may be completely unique. You walk now along the edge of a frozen field lab, imagining petri dishes glowing under ultraviolet light samples, humming with chemical reactions invisible to the eye. The researchers here are trying to map the microbial geography of Antarctica to understand which organisms live where and why. Do they travel between lakes carried by subglacial rivers? Do they evolve independently in isolated pockets? Are some truly ancient lineages unchanged for millennia? Or are they newer, descended from hardy invaders who found their way in through cracks and meltwater pathways? You look up at the vast white expanse and it hits you life didn't give up on Antarctica. It just went quiet. It adapted. It squeezed into rocks. It curled up in salt. It drifted beneath glaciers. It paused for a few thousand years and then resumed as if nothing happened. And perhaps the most chilling realization of all, there may be life here that we've never seen before because it doesn't look or behave like anything we expect. We're still using Earth-based definitions of life. But what if Antarctica is quietly rewriting them? What if alive means something broader? What if survival isn't the exception, but the design? You breathe out and your breath fogs the air. A few microbes land on your jacket. You won't see them, you won't feel them, but they're there dormant, patient, ancient, and they're not done yet. Because Antarctica isn't just a frozen desert, it's a library of survival. And the most interesting stories, you haven't read them yet. The silence is different out here, not the kind that swallows you in nature's stillness. This silence feels man-made, intentional, like something once filled it, but then vanished. You brush frost from a sign buried in snow, faded letters, a rusted pole, the remnants of a flag shredded to threads by wind. This is one of Antarctica's many abandoned research stations, eerie skeletal remains of human ambition left to freeze in place. They dot the landscape scattered across the continent like footprints from a forgotten parade. Some are no more than wooden shacks with warped doors and broken windows. Others are full-blown outposts, metal bunkers, satellite dishes, storage units sealed shut by decades of snowdrift. Most are too remote to reclaim, too dangerous to remove. So they remain silent, half-buried, and slowly being swallowed by the ice. You step over a collapsed beam into the husk of a communications room. A tangle of wires, an empty rack of batteries, a desk still holding a weathered notebook, its pages frozen together. It feels like walking into a story that was paused mid-sentence. This was once home to someone. For weeks, maybe months. Scientists, technicians, meteorologists, people who left their families, boarded cargo planes, and came down here to live in one of the harshest environments on Earth, all in the name of science. And then at some point, they left. Some stations were abandoned due to budget cuts or the opening of better-equipped facilities. Others were overtaken by ice movement structural collapse or simply deemed too remote to be useful. In a few cases, entire teams were evacuated during emergencies, fires, blizzards, or medical crises, leaving behind everything but their boots. You stand in a narrow corridor, the floor creaking under your weight. A mug sits on a shelf rim, crusted with coffee ice. A calendar from 1976 hangs on the wall, its pages frozen in time. There's something haunting about these places. Not because they're dangerous, though many are, but because they remind you how fragile our presence here really is. How out of place we are. Antarctica doesn't care if we build bunkers. It doesn't care about Wi-Fi diesel fuel or human comfort. It moves, it waits, and eventually it reclaims. One of the most famous ghost stations is East Base, used by the US during the 1940s and again in later expeditions. Built of timber and steel, it now stands as a historic site, preserved not for function, but for memory. Inside, you'll find jars of food books and even handwritten letters. Messages never sent, thoughts never heard. Even more eerie is Vostok Station, a still active Russian outpost, but parts of which are falling apart due to neglect and extreme cold. Here, machinery hums in one room, while another has collapsed entirely under snow. A hallway can take you from the 21st century into something that feels like a Cold War time capsule. Historians still debate what should be done with these relics. Some argue they should be cleaned up, removed for safety, for environmental protection, for respect. Others say they should be preserved, that they're part of Antarctica's human history, that we need these ghosts to remember just how far we've come and how easily we could disappear again. You move deeper into the structure, your flashlight catching on a stack of dusty cassette tapes, labeled weather logs. One is marked, "Do not erase." The irony stings. Not all abandoned stations are from the distant past. In 2012, Britain's Halley 6 research station had to be relocated because a massive crack, the Brunt ice shelf rift, threatened to tear the station's foundation apart. And that's a modern mobile structure. For older buildings built before we truly understood how ice flows, their fate is sealed. There are stations out there forgotten by governments, untouched by rescue crews, whose precise locations are now uncertain. Swallowed by snow, crushed under shifting glaciers. Some are entombed like time capsules, buried under layers of white. Others just drifted away. And let's not forget the graveyards of equipment-rusted snowmobiles, supply crates drilling rigs left where they failed. Antarctica is littered with artifacts. Not in the archaeological sense, but in the quiet, rusting proof that even the best prepared missions can be humbled here. You exit the station and step into the pale daylight again. It's quieter outside. The wind has stopped for now, but it's the stillness that unnerves you most. There are no birds, no bugs, no trees creaking in the wind, just the groan of distant ice and the whisper of memory. You wonder what stories were told inside that station, what discoveries were made, what secrets were recorded on those frozen notebooks, and what dreams were packed away when the last plane lifted off. Maybe one day someone will stumble upon a newer station in this same state. Maybe we are the next ghosts, because Antarctica doesn't need us. But it does remember us in empty bunks, in frozen footprints, in coffee mugs and pencil marks, in the hum of machines left running too long, in the silence left behind when the door finally closed. You take one last look at the ghost station, its walls half consumed by snow, and continue walking. And though no one's lived there in years, you can't help but feel that someone is watching you from the darkened window. Or maybe it's just the ice, remembering the snow crunches softer beneath your boots now. The landscape ahead shifts again, no longer sheer white, but streaked with ridges of wind-blown rock and ice-polished hills. You're approaching one of the continent's rare exposed zones, where the ice thins just enough to reveal a glimpse of something strange, ancient, and altogether unsettling. It's called the Gomburtsev mountain range, and it shouldn't exist. Buried beneath up to 4 kilometers of ice in East Antarctica lies a massive mountain chain, roughly the size of the Alps, with peaks reaching thousands of meters in height. But unlike the Alps, these mountains haven't seen sunlight in millions of years. No explorer has ever stood atop their ridges. No animal has ever climbed them, and no human eye has ever seen them directly. They are the ghost mountains of Antarctica. Their discovery in the 1950s stunned scientists. Using seismic surveys during the International Geophysical Year, researchers bounced sound waves off the bedrock and found something unexpected, a jagged complex range of peaks hidden beneath the thickest part of the East Antarctic ice sheet. The obvious question arose: why are there mountains there? How did they form? And how have they stayed so perfectly preserved? Theories began to form. Some scientists believe the range was born more than 1 billion years ago during an ancient collision of continental plates. Others think it may be younger shaped during the same tectonic upheavals that created the modern Himalayas. But regardless of their age, there's a bigger mystery. Why didn't they erode away? Typically, mountains weather down over time, especially under glaciers. But the Gomburtsevs seem to have retained their sharpness, their steepness. Radar imaging suggests steep valleys, angular peaks, and even river-like ridges beneath the ice. It's as if they were frozen in place, just after forming locked in a geological deep freeze. You stand atop a ridge, now staring down at what lies beneath your feet. Miles below these peaks remain hidden, unreachable, untouched. And yet they shape the world above them. That's the other twist. The Gomburtsev Mountains aren't just geological oddities. They're ice architects. Their presence beneath the East Antarctic ice sheet may have been essential to the formation of the ice sheet itself. The high peaks likely caught early snowfall, which built up and eventually seeded the massive glacier that now spans the continent. In other words, these hidden mountains may have made Antarctica what it is today. And they're not alone. Elsewhere beneath the ice, there are other strange formations, subglacial valleys, massive canyons, and fossilized river systems. The Denman Glacier, for example, sits in a trench that drops more than 3.5 kilometers below sea level, the deepest land-based point on Earth not covered by ocean. A sort of negative Everest carved not by erosion, but by glacial forces we still don't fully understand. As you shift your weight on the ice, you realize that you're not standing on flat ground. You're standing on a roof, a ceiling over an ancient landscape. Mountains, valleys, riverbeds, all sealed in darkness, locked away, since before humans ever existed. There's something humbling about that, but also something haunting. Because deep beneath the ice, preserved like a perfectly refrigerated tomb, might lie fossils. not just of plants, but perhaps animals, insects, creatures from a time when Antarctica was green, before it drifted south, before it froze over, before it forgot the sun. Some scientists believe sediment buried in the valleys around the Gamburtsev Range might hold the best preserved evidence of ancient Antarctica's ecosystems. Microfossils, pollen, maybe even DNA. If we could drill carefully enough, we might pull up a snapshot of life from 100 million years ago. But the drilling isn't easy. The ice above the Gamburtsevs is some of the coldest and thickest on Earth. Boreholes are expensive, dangerous, and controversial. There's the risk of contamination, the risk of destabilizing ancient formations, and always the question of what happens if we disturb something that was meant to stay buried. Historians still debate whether we should explore these mountains further or leave them alone. Some say the data could be invaluable not just for understanding Antarctica's past, but for predicting Earth's future. Others warn that drilling into such pristine zones might compromise the very mysteries we're trying to understand. And then there are those who suggest that something is already watching. You laugh a little at that. It's absurd, of course. But even you have to admit, there's a presence out here. An awareness, maybe. Or just your mind playing tricks in the vastness. Still, what else could be buried down there? The Gamburtsev Mountains are larger than some countries. Entire ecosystems could have existed in their valleys before the ice came. Rivers may have flowed between peaks. Forests may have clung to the cliffs. And when the glaciers descended, they would have frozen everything. Plants, soils, and anything else in place. Paleoclimatologists dream of accessing these records. The isotopes in that ancient sediment could help model how Earth's climate shifted through the millennia. They might tell us why Antarctica froze when it did, or what might happen if the ice melts again. Because here's the other truth: the ice won't last forever, and when it melts, slowly, steadily, it will begin to unveil what it's kept secret for millions of years. A landscape no one has seen. A range of peaks that never knew our names. A world older than civilization, hidden right beneath your feet. You stare at the horizon, knowing that miles below you is an entire kingdom of stone, majestic, unmoving, and yet never seen by human eyes. Not yet, but one day, when the ice gives up its grip, the Gamburtsev Mountains will rise again, not in a roar, but in a thaw. And when they do, we'll finally see what kind of world the ice was hiding, and why it took so long to show us. You're starting to realize something about Antarctica. The deeper you go into its stories, the more it slips out of your grasp. It doesn't just hide answers, it hides the questions too. And few places embody that better than what you're approaching now, a featureless plain of ice that somehow contains one of the most mysterious, controversial, and misunderstood places on the entire planet. It's called Lake Vostok. From the surface, there's nothing to see, just snow, wind, cold. But buried beneath nearly 4 kilometers of solid ice, Lake Vostok stretches over 150 miles in length, covering an area roughly the size of Lake Ontario. And it has remained sealed off from the surface for possibly 15 million years. Let that number roll around in your head for a second. 15 million years. That means no sunlight, no atmosphere, no connection to the biosphere. Just complete isolation under intense pressure and total darkness. And yet Lake Vostok may still be alive, discovered via radar surveys. In the 1990s, Vostok stunned scientists by its sheer scale and by the fact that it's liquid. how two things: geothermal heat from the Earth's interior and the insulating effect of the thick ice sheet above it. Together, they keep the lake from freezing solid, even in the coldest environment on Earth. And here's where the mystery deepens. In 2012, after years of effort and setbacks, Russian scientists finally drilled down to the surface of the lake. Their borehole pierced the ice, and pressurized water from below surged up and froze instantly in the shaft, a sample from a place untouched by the rest of the planet for eons. What they found in that frozen plug shocked everyone. Traces of unusual life forms, bacteria, mostly some of which seemed genetically different from anything known on Earth. Not alien exactly, but weird enough to raise eyebrows. A few sequences were close to known extremophiles, others entirely novel. Some scientists argued that they were contaminants. Others weren't so sure. The debate still rages. Historians and biologists argue over the integrity of the sample. Was the life from the lake itself or from the drilling fluid? Were the tools clean enough? Was the borehole truly sterile? The Russians insist yes. Many Western scientists remain skeptical. But even if the sample was compromised, the idea that life might exist in Lake Vostok remains not only plausible, but likely. And that changes everything, because Lake Vostok is just one of more than 400 known subglacial lakes beneath Antarctica. If life is possible here without sunlight, oxygen, or external nutrients, then it could be everywhere down there, and not just microbial. Some researchers theorize that larger organisms, tiny crustaceans, worms, or even primitive fish, might have evolved in isolation within the lake. It sounds wild, but think about it. Isolated ecosystems often drive rapid specialization. Look at the blind cavefish in Mexico, the strange eyeless shrimp in deep-sea hydrothermal vents. What if Lake Vostok has its own evolutionary timeline? You imagine peering through a crystal window of ice looking down into that dark abyss. The water perfectly still. The pressure immense. Then from the darkness, movement. A flicker. A shape. Something that shouldn't be there. And yet is. And of course, that's where the theories begin to spiral. Some say the lake isn't natural, that the smoothness of its bottom and the linear patterns in radar scans suggest artificial structures beneath the ice, ancient architecture, lost civilizations, even evidence of pre-human intelligence. There are claims of heat signatures, of magnetic anomalies, of straight lines that run too perfectly to be natural. The alien base theory gets trotted out here again. Tired? Sure, but persistent. If something came to Earth long ago and wanted to hide, wouldn't a subglacial lake in the coldest, most remote place on the planet be the perfect vault? You don't buy it, but you also don't rule it out completely, because Lake Vostok is still mostly a mystery. Most of it has never been sampled. No one has sent a submersible into its depths. No camera has captured its interior. It remains, for now, an untouched world as foreign as any moon in our solar system. NASA certainly thinks so. They study Lake Vostok as an analog for Europa and Enceladus, the icy moons of Jupiter and Saturn. Both are believed to have subsurface oceans beneath thick ice crusts. If we want to drill into those alien seas one day, we need to practice on Earth first, and Vostok is the best practice ground we have. But that raises a problem. Do we risk contaminating what could be one of the last truly pristine ecosystems on Earth? The very act of drilling can introduce bacteria, chemicals, and warmth that weren't there before. If Lake Vostok holds unique life, we might kill it before we even know it exists. Or worse, we might introduce something from below to the surface. Something adapted to live in pressure, and darkness released into a world it hasn't known for 15 million years. Historians still debate the ethics of deep exploration in Antarctica. Some call it science. Others call it intrusion. The Antarctic Treaty provides guidelines, but enforcement is tricky, and the thirst for knowledge is hard to resist. You crouch now beside the capped borehole, long frozen over, but still marked by steel and wire. Somewhere below your feet, a hidden ocean waits, silent, cold, maybe alive. What if it's watching? What if it's listening? You stand again, scanning the horizon. All you see is white. But now you know what's below it. Something vast, something old, something sealed off from the rest of life on Earth. And maybe that's exactly how it should be, because some doors stay closed for a reason. And Lake Vostok, it's still knocking from the other side. The wind picks up again as you move on, this time from the south. It carries a scent so faint, so strange, that you almost miss it. Not salt, not ice, not ozone. Something else. Old wood, maybe. Engine grease. Something left behind. You're nearing the coast now, not the jagged wave-blasted cliffs you might expect, but a frozen shoreline. A place where sea and ice collide, and strange things have a way of drifting in, then never drifting out again. Here is where the stories start. You've reached the graveyard of one of Antarctica's eeriest mysteries ghost ships. They don't get talked about as often as Arctic shipwrecks, no Franklin expedition, no mythic Northwest Passage disasters. But that doesn't mean the Southern Ocean hasn't claimed its fair share of vessels. Some went down fighting waves. Others vanished with no distress calls. And a few came back empty. One such story begins with the Balleny Islands, northeast of the continent, where researchers once spotted a small vessel floating in open water. No radio response, no crew visible on deck. Upon closer inspection, they found the ship intact, food still in the galley clothing, neatly folded, even half-written entries in a logbook, but no people, no signs of violence, just silence. The ship was towed back, its records combed through. And to this day, no one knows what happened to the crew. Vanished, evaporated, taken by a rogue wave, slid overboard in darkness, or something else. Antarctica doesn't offer many explanations, just possibilities. You remember the tale of the Southern Queen, a whaling vessel from the early 1900s that disappeared without trace while charting the edge of the Ross Ice Shelf. No distress signals, no wreckage. Months later, one of its longboats was found on a beach hundreds of miles away, perfectly preserved, frozen in place, with fresh sealskin coats tucked inside. No bodies, no footprints, just that awful hanging question: what happened? Even modern vessels haven't escaped the pull of the Southern Ocean's secrets. In 2014, the Akademik Tucholsky, a Russian research vessel, became trapped in thick Antarctic sea ice, despite having GPS weather forecasts and satellite support. For weeks, it was surrounded by shifting ice and unpredictable winds. It took multiple nations and 3 ships to rescue the crew. But that wasn't the strange part. That part came later, when instruments from the mission recorded unexplained sonar returns, massive, slow-moving shapes under the ice that never broke the surface. Data was dismissed, but the files are still there, waiting. You walk along the frozen coast, where the ice is pocked with dense and half-buried metal. The remains of vessels too damaged to recover. Some lie upside down, their hulls split, their names long since sandblasted away. And beyond the shore, the waters get stranger. The Southern Ocean is infamous for something sailors call the Roaring Forties and Furious 50s wind bands that whip around the globe at nearly unbroken speed. These winds stir up colossal waves, sometimes over 60 feet high, that crash through the Drake Passage and slam into ice shelves like sledgehammers. Many vessels caught in these maelstroms don't sink in flames or get shredded by rocks. They simply disappear, gone without a whisper. Historians still debate the number of missing ships in this region. Hundreds are documented. Dozens more are assumed. And now, with changing ice conditions and better underwater mapping, we're starting to find them, or parts of them. In 2022, a submersible drone surveying the seabed near the Larsen C ice shelf came across something unexpected, a field of twisted iron half buried in silt. At first, they thought it was geological, but sonar scans revealed rivets beams, even propeller fragments too old to be modern, too deep to be recent. Possibly part of a long-lost expedition that vanished during the heroic age of Antarctic exploration. And then there are the lifeboats. Several have been found over the years, some drifting, some frozen into sea ice, some marooned on the coast. Often, they're empty. Sometimes, chillingly, they're still packed with supplies, blankets, food rations, flares, but no people. You stand by one now, an old whaling boat, barely more than a ribcage of wood and rusted iron. It rests, tilted on the rocks, half buried, as if trying to crawl back into the sea. Nearby, a length of rope sways in the wind like a forgotten signal. It's hard not to let your mind wander. What if the crew never left the boat? What if something waited in the fog or in the water? Because Antarctica's coast is haunted not just by missing sailors, but by sound. Hydrophones in these waters have picked up unexplained underwater noises for decades. Whistles, booms, metallic groans. Some are attributed to ice calving or glacier quakes, natural if unnerving. Others don't fit. One such sound, nicknamed the upsweep, has been detected seasonally since the late 1990s. Origin unknown. Some say it could be volcanic. Others suggest it's biological, a massive, deep ocean creature using sound to communicate in frequencies we can't hear. And sometimes, ships report hearing things too. Muffled banging, screams and static, echoes with no source. Most are dismissed. Stress, ice shifting, equipment interference. But if you spend enough time out here, especially near the coasts where water and wind conspire, you start to wonder what else is drifting beneath the surface. What else calls this place home? You step back from the lifeboat and watch as the fog rolls in from the horizon, erasing the sea, the sky. And finally, even the outline of the old boat itself. Another vanishing, another story waiting to be discovered or never told. Because here in Antarctica's forgotten harbors and silent bays, the ghosts don't scream, they just float. The fog clears just enough to reveal something new on the horizon, a gleam, a pattern, something not quite natural in its symmetry. As you approach, it sharpens. Not a rock, not a glacier. A structure, at least that's what it looks like. But how could there be a structure here? You've stumbled into the heart of one of Antarctica's strangest puzzles, the mystery of anomalous geometric patterns found in satellite imagery across the continent. Images that spark curiosity, outrage, excitement, and more than a few outlandish claims. What you're seeing is a hexagonal ridge of snow and ice with unnaturally straight lines and sharp corners. At first glance, it resembles a building, perhaps a buried pyramid. or an underground entrance. Google Earth forums light up with every new find like this. Speculators shout about ancient civilizations, Nazi hideouts, or even alien bases. Scientists, meanwhile, shake their heads. Pareidolia, they say. Your brain seeing patterns in randomness. But is it? You kneel by the ridge and feel the ice beneath your gloves, firm, smooth, in places almost too uniform. You know ice can sculpt strange things. Wind can carve. Snow can drift into precise angles. But the sheer regularity of some formations defies easy explanation. One of the most famous examples is located in Ellsworth Land, where satellite scans revealed what some described as a perfect pyramid, four faces, aligned in cardinal directions, with sharp edges visible even from orbit. Mainstream scientists explain it as a nunatak, a mountain peak, protruding through the ice shaped over time by natural erosion. Yet that doesn't stop the speculation. Could an ancient civilization have once lived here? Could their structures be buried beneath miles of ice preserved, like bones under skin? Antarctica wasn't always a frozen desert. You've already seen the evidence, the forests, the fossils, the flowing rivers of a forgotten age. So if intelligent life ever did exist here, might it have built something permanent, something grand? Historians still debate whether humanity's historical timeline is as complete as we think. There are vast gaps periods where evidence is thin, where oral histories fade, and where geography like Antarctica's makes excavation nearly impossible. And then there's the Antarctic anomaly, a term coined after a 2006 satellite scan of the Wilkes Land region revealed a massive gravitational anomaly beneath the ice. A dense mass of something deep underground, nearly 200 miles across. No one knows exactly what it is. Some say it's the remnant of an asteroid impact. Others claim it's a huge deposit of dense rock. But a few fringe thinkers and curious scientists alike have proposed something else, that the anomaly might be the ruins of a megalithic structure or even the outline of a buried city. You rise and look out across the ridge, its unnatural edges glowing in the pale sun. Whatever created this be, it wind ice or ancient hands, it draws you in. Of course, we have no proof of a lost Antarctic civilization. No bones, no pottery, no writing etched into stone. Just shapes seen from the sky and whispered about in the dark. But isn't that how mysteries start? You remember the Piri Reis map, a 16th century Ottoman world map that some claim shows the coastline of Antarctica without ice. Scholars argue it's a misunderstanding, that the map likely references South America with artistic distortion. Still, believers point to the map's strange precision, its pre-modern details, and ask, how could anyone have known what Antarctica looked like before we officially discovered it? Another coincidence, another trick of the mind. You walk a few steps farther and see another pattern in the snow, a series of long, evenly spaced ridges. Maybe natural, maybe not. But your heart ticks a little faster. In recent years, ground-penetrating radar has discovered angular features buried beneath the East Antarctic ice. Some look like straight walls, others like corridors. One set of features even formed a near-perfect rectangle 400 meters wide. Cracks, some said, ice flow lines. But the radar signatures were dense too, dense to be ice alone. Still, expeditions are slow. Funding is tight, and the treaty-bound restrictions on digging too deeply, too widely, too recklessly mean most of these anomalies go undisturbed, unconfirmed, unsolved, because if you dig in Antarctica, you must be gentle. You must not contaminate. You must not disturb ecosystems that have never known sunlight. The rules are clear, but maybe they're also convenient. Some claim that governments already know what lies beneath, that certain sites are off limits, not because of environmental concerns, but because of what might be found there. You try to ignore the whispers of conspiracy, but still, the mind wanders. A world swallowed by ice, a society lost in the snow, a city beneath your boots. You touch the ridge again, cold, silent, unyielding. Maybe it's just ice. Maybe it's something more. You keep walking, because out here, every shadow is a question, and every angle an invitation. You press forward into the wind, leaving behind the sharp angles of that snow-covered anomaly, and the terrain shifts once again. This time, it's not what's beneath your feet that draws your attention. It's what's above your head, a shimmer in the air, a ripple across the sky, a flash of something green, then violet. You've entered Antarctica's strangest storm, the place where the sky catches fire. It begins with the aurora australis, the southern lights, an electric ballet that dances across the polar heavens. It's the twin sister of the northern lights, but somehow quieter, more secretive. Few people have ever seen it from here, and fewer still understand what's really happening when those curtains of color ripple across the stars. Above Antarctica, the auroras aren't just pretty. They're intense. Caused by solar wind slamming into Earth's magnetic field, they create glowing rivers of plasma that stretch for hundreds of miles across the sky. They bend and twist and pulse, flashing in greens and reds and purples. You stop and stare up. The lights feel closer here, and maybe they are, because this place isn't just where the sky glows, it's where Earth's magnetic shield is weakest. Welcome to the South Atlantic anomaly, a mysterious distortion in Earth's magnetic field that stretches toward Antarctica like a bruise. It allows more radiation from space to seep in, disrupting satellites, frying electronics, and confusing compasses. Space agencies even shut down their instruments when passing overhead, and underneath that anomaly, the ice. And beneath the ice, still more questions. Some researchers believe this magnetic weakness may be tied to changes in Earth's core, a shift in the molten iron below that creates the magnetic field in the first place. Others think it may be a temporary dip, part of the natural drift of Earth's magnetic poles. But there's also a theory less popular, more unsettling, that the magnetic field is in the early stages of flipping. Yes, flipping. Earth's magnetic poles have reversed many times throughout history. North becomes south. South becomes north. It's happened before scientifically proven. The last full reversal was around 780,000 years ago, and it's not a clean process. The field weakens, wobbles, becomes patchy and chaotic. Radiation creeps in. Satellites malfunction. Migration patterns in animals go haywire. And if it were to happen again, some of the first warning signs would appear. Right here, in Antarctica, where the field is already weakest. Where strange anomalies shimmer in the sky. Where unexplained radio pulses sometimes echo from the upper atmosphere. In 2016, scientists working with the Antarctic Impulsive Transient Antenna, ANITA, for short, detected cosmic rays that appeared to be traveling the wrong way up from the ground instead of down from space. It shouldn't have been possible. Cosmic rays come from space. They hit the atmosphere from above. But these signals came from beneath the ice. NASA reviewed the data. So did physicists around the world. Some thought it might be a reflection or glitch. Others proposed something more exotic. The particles may have passed through the Earth as part of a parallel universe or a new form of physics entirely. Wild, absolutely, but the data still unexplained. You step slowly across the snow, now glancing upward at the aurora pulsing above. It doesn't feel distant anymore. It feels connected, as if it's not just a light show, but a signal, a beacon. And you realize that Antarctica is more than a frozen landmass. It's a portal, a place where Earth's systems brush against space, where the deep past touches the future, where radiation magnetism and temperature extremes form a kind of natural laboratory for the unthinkable. Historians still debate the earliest records of magnetic shifts. Some claim that sudden pole changes may have wiped out civilizations in the past. Others argue that the changes were gradual, barely noticed in human terms. But all agree if the poles flip again, we'll see it start in the polar regions. And this time, we'll be watching satellites, telescopes, sensors buried in ice, all scanning the skies and the Earth's crust for hints. But the truth is, we don't really know what will happen. We've never lived through one of these shifts with our current tech-heavy civilization. What happens to GPS, to power grids, to climate? We're not sure. But if you want to know where the first ripples will rise, you've already found it. Right here, where the ice meets the stars. You sit down on a flat stretch of snow, your breath rising into the cold air like smoke, and watch the sky swirl with unnatural color. The aurora flares again, sudden, sharp, a whip crack of green lightning, and then softens, as if the sky is exhaling. You wonder what it means. Is the planet changing? Or is it just waking up? You remember the data from Anita, the radiation spikes, the magnetic oddities. You remember that the same solar winds painting the sky also carve away at satellites, disrupt signals, and whisper strange truths into instruments most of us will never understand. You remember that Earth is not a static place. It shifts, it tilts, it pulses, and nowhere more so than here. Antarctica is a canvas where space and Earth collide, a liminal zone glowing with beauty and humming with dread. You lie back in the snow, feeling the cold seep through your jacket, and look up one more time. The lights above are still dancing, but now they don't look like random swirls. They look like warning signs. And maybe, just maybe, they're not dancing, they're blinking. Your eyes adjust slowly as the aurora fades, replaced by a pale, eerie darkness that seems to come not just from above, but from within the ice itself. The air still hums faintly, not with sound exactly, but with pressure, the kind that makes your ears pop and your thoughts feel distant. Because now you're approaching the part of Antarctica that doesn't just confuse scientists, it unsettles them. You're heading toward the Dragon's Breath Zone, a name whispered more than recorded, a phrase used informally by glaciologists and satellite analysts. It refers to a series of strange thermal anomalies detected by infrared sensors across the continent. Places where the ice shouldn't be warm, but is. Tiny hotspots, narrow streaks of inexplicable heat, bursts of subglacial vapor escaping from cracks that weren't there yesterday. No one talks about them officially, not in the open, because there's no consensus, no theory that fits all the data. Some say it's geothermal, venting from deep within the crust. Others blame shifting tectonic plates, or perhaps slow pressurized lakes releasing their steam like the breath of some buried leviathan. But then there are the ones who suggest something else entirely, that these zones aren't natural, that they're reactive. You pause at the edge of a known hotspot, a site once visited by a research drone, now marked as inaccessible. There's no visible danger, no cracks or flames, just a strange shimmer to the air, like heat rising from a summer highway. But this is 50 degrees C. That shimmer shouldn't be there. You crouch and dig a little with your glove. Just snow at first, then a thin crust of frost, and beneath that, the unmistakable softness of melt, warm ice. No geothermal vent has been found directly beneath this spot. No volcanic trace. No recorded seismic activity. It's just warm, persistent, growing. One of dozens like it, and they're not random. When you overlay the known hotspots on a satellite map, a pattern begins to form. Not a grid, not lines, but a web, like veins radiating from a central point, or like cracks in a shell. A fracture map, the center, somewhere near Lake Vostok. Historians still debate whether ancient lore ever spoke of the South Pole. The Greeks thought of it as Terra Australis Incognita, the unknown southern land. Some Aboriginal oral traditions passed down over millennia speak of frozen worlds and distant lands of fire beneath snow. Are they allegory or memory? In 2018, a multinational team sent seismic equipment to one of the more active breath zones. Their instruments picked up low-frequency rumbling, rhythmic and strange. Not an earthquake, not wind. More like breathing. It continued for 17 hours, then stopped. The data was analyzed, written up, and quietly shelved. Official explanation: glacial resonance. But among the team, no one believed that. One of the engineers quit the field entirely. Another developed debilitating tinnitus, not uncommon in cold climates, but strangely timed. You step away from the hot spot and look out over the ridge. In the near distance, a narrow column of fog twists into the air like smoke from a candle, a mini plume. It vanishes just as quickly as it appeared. Some believe these sites could be natural release valves, the pressure of trapped gases from decaying biological matter or from deep under Earth's mantle, finally escaping through weaknesses in the ice. Others suggest they could be signs of subglacial volcanic systems, more active than previously believed. The West Antarctic Rift System, after all, is full of volcanoes, many buried under ice. Some still warm, some possibly erupting beneath the glacier in slow motion without ever reaching the surface. But even that doesn't explain everything, because the hotspots don't align perfectly with the volcanic zones, and sometimes they move, not fast, but enough to be noticeable across monthly satellite scans. They shift, like something turning beneath the ice, something changing direction. You don't want to think about that. You focus instead on the facts, the data. The anomaly maps the tremor logs, the sudden fluctuations in magnetism detected near these areas. You remind yourself that the Earth is dynamic. It breathes, it cracks, and reshapes. Antarctica is just part of that system, but then your thoughts drift to something you heard once, not from a scientist, but a former military analyst who worked on Arctic sonar arrays. He said Antarctica was the one place they never understood. The silence there, he said, was different. It wasn't just absence. It was enforced. You didn't ask what he meant. You wish you had. You stand now in the center of the Dragon's Breath Zone. Your boots leaving soft impressions in snow that's warmer than it has any right to be. The air is quiet, but it's not empty. You feel watched, and not in a paranoid way, more like a memory being retrieved. Like the ice knows you're here. Like it's waiting for you to ask the question no one wants to answer. What if Antarctica isn't just a continent? What if it's a system? not living in the way we understand, but conscious, patterned, reactive. Or worse, what if something alive is using it? You shake off the thought. Too much time in the cold, too many strange stories. But as you walk away, you glance back one more time, and you swear the fog column rises again, then slips away like a sigh. A long, tired sigh, as if something beneath the ice just rolled over in its sleep. And maybe, just maybe, it's dreaming of a time when this place wasn't quiet. And when it wakes, the silence might not be enough to stop it. The sun skims low on the horizon, now casting long, pale shadows across the snow like fingers stretching towards something forgotten. You've been walking for hours, maybe days. Time here has a way of folding in on itself. And now you're approaching the very edge of what most maps will show. Here, in this no man's land of white and wind, is the realm of the forbidden zones. They're not marked by signs. You won't find fences or border stations. But ask the right people, the ones who've flown supply runs or filtered satellite data, and they'll tell you there are places in Antarctica you're not allowed to go. Not because they're too dangerous, but because someone decided you shouldn't. It starts innocently enough. A research team applies for access to an unmapped zone, perhaps to investigate a thermal signature or an unusual radar reading. The request is denied, not indefinitely, just pending review. That review never comes. Months pass. The application is closed. The area is reclassified either for environmental protection or geological instability. That's the polite version. Other times it's more blunt. Satellite images are blurred or scrubbed. Flight paths are rerouted. Unmanned drones are blocked with signal interference. Teams are told to leave their current site and return to base without explanation. In 2013, a glaciology crew from Europe was conducting seismic studies near the Prince Charles Mountains when they detected a strange void beneath the ice, long, rectangular, possibly hollow. The data was forwarded for analysis. The next day, the team was ordered to halt work and return to their station immediately. They weren't told why. Their instruments were confiscated upon arrival. And when they got home, the anomaly was missing from the final report. You stand now near one such region, marked only by silence. There are no trails leading in, no signs of footprints, just a wide stretch of featureless snow, and beyond it, a dark slope that rises unnaturally smooth, a buried structure, a volcanic dome, or something else. There's no official explanation, only rumors. Some say it's the entrance to a classified research facility jointly operated by multiple nations, a place where deep ice cores are stored, where genetic samples from ancient microorganisms are kept under extreme containment. Others believe it's older than that there's something buried here, something we didn't put there. Satellite photos leaked online in 2018 showed a strange hexagonal depression near this zone. The image circulated for a few weeks, then vanished. Some claimed it was a digital artifact. Others swore it showed an artificial structure, partially exposed by melting ice. No confirmation ever came. Historians still debate whether such off-limits areas are really about protection or concealment. Antarctica is the only continent governed by a treaty of peaceful cooperation. The Antarctic Treaty forbids military activity, weapons testing, and territorial claims. But it's also ripe for secrecy, with remote locations, no permanent population, and limited oversight. If you wanted to hide something, there are few better places on Earth. You remember a story from a former pilot who flew missions in the late 90s. He described being redirected mid-flight away from a certain zone, even though no storms were visible and no airspace warnings had been issued. Later, he saw photos taken from earlier missions showing strange geometric shadows in that same location. He never flew again. You look now at your own GPS. The screen glitches, stutters. You check your backup compass. It spins lazily, then settles in the wrong direction. That happens sometimes out here. Magnetic anomalies, solar interference, glitches. But too many glitches in one place start to feel like a message, and yet there's no one to ask. No tour guides, no officials. Just the wind, the cold, and whatever might be buried under miles of compressed time. You take a few cautious steps forward. The snow here feels strange. Softer in some places, unnaturally firm in others, like it's resting on something hollow. You kneel down and press your glove against the ground. There's a faint vibration, not seismic, more like the hum of distant machinery. You hold your breath. It continues. Some claim these zones protect deep geothermal labs, places where the crust is thin, where the ice is warm, and where experiments in microbial life and biochemistry are ongoing. Others think the vibration is natural tectonic shifting under glacial weight, but some believe something older is stirring. Legends speak of ancient machines buried in ice, devices from a forgotten age, or visitors from elsewhere, trapped, preserved, waiting. The vibration stops. You stand scanning the horizon. There's no visual clue, no smoke, no noise, just snow. And still, you're sure of it now. Something here is active, but you'll never know what it is, because this zone is off limits, not just to you, but to truth. And that's the most Antarctic thing of all, the way it doesn't argue, doesn't explain, just denies you and keeps its secrets. There's a numbness in your legs now, not just from the cold, but from something else. A quiet weight. The kind that settles in when you've seen too much, asked too many questions, and realize you're still no closer to answers. Antarctica will do that to you. It doesn't reveal. It withholds, but still, you keep walking, because now you're reaching one of the strangest and most unsettling stories of all the kind whispered behind closed doors in science labs and quietly dismissed in official statements. The case of the vanishing beacons. It started quietly enough. In the early 2000s, several automated GPS tracking stations called beacons began going offline. These beacons are critical. They help monitor glacier movement, track atmospheric conditions, and support navigation for aircraft and remote expeditions. They're robust, solar-powered, designed to survive Antarctic winters. Some even buried under protective ice domes. But then, they started disappearing, not failing, vanishing. One day, the signals would be active. The next, gone. Recovery teams were dispatched. Some sites were found with all equipment intact, but completely non-functional batteries, drained solar panels shattered in ways that didn't match weather patterns. Others were never found at all. You approach the location of one such lost beacon now. The GPS coordinates say you're close, but there's nothing here, just wind-blown snow and a faint impression in the ice, a shape too square to be natural, too faint to trust. You scan the area. No metal glint, no tracks, just emptiness. This particular beacon was last seen broadcasting from here in 2011. Its final message, a string of routine data, and one unusual blip, a magnetic anomaly rising quickly in intensity, then flatlining. Scientists dismissed it as solar interference. But the same signature was found at 3 other sites, all shortly before the stations went silent. A coincidence? Maybe. But that's the thing about Antarctica. It builds coincidences, like frost builds on glass. One layer at a time until you can't see what's underneath anymore. In 2015, a research drone flying a high-altitude thermal scan picked up a brief flash of heat in a remote zone west of the Transantarctic Mountains, a spot with no known activity, no bases, no human presence. The thermal bloom lasted only 6 seconds, but it was massive, more intense than anything the team had recorded outside of volcanic eruptions. When a second drone was sent to the location, it encountered extreme turbulence and had to return. The third never came back. Its last transmission, a still image of something. No one could agree on what it showed. A line, a light, a curved shadow half buried in ice. The image file was quietly removed from the database. The official reason: corrupted telemetry. You move forward carefully, now reaching what was once a camp built to study the aurora. It's long abandoned, stripped for parts overtaken by snow. But one structure remains: a metal tripod, embedded deep in the ice, the base of a beacon. The rest is missing. No wires, no tower, no panels. Just a metal foundation, fused into the permafrost. You kneel beside it and brush away the frost. There beneath the snow, you find something odd. A faint scorch mark. A burn. But how? This isn't a place of fire. You look around and realize how alone you really are. No sled tracks, no radio towers, just a sky so wide it feels like it's listening. Some scientists believe these vanishing events may be linked to shifts in Earth's magnetic field, especially around the South Pole, where the field lines are dense and erratic. Sudden pulses of energy could fry circuits, or confuse software, or in extreme cases, cause localized EMPs, electromagnetic pulses. Others blame microbursts from solar storms redirected toward Earth by polar ion funnels. It sounds plausible, scientific, clean. But then there are those who don't talk in terms of natural causes. They speak of zones of silence areas, where electronics die, animals flee, and people report feelings of dread or disorientation. Places where reality feels thinner, more fragile. You once heard a researcher describe walking into one of those zones and suddenly forgetting why he was there, as if a curtain had dropped between his memory and his thoughts. He stood for 20 minutes before snapping out of it. His equipment never turned back on. The logs of that mission lost. His team doesn't talk about it. Historians still debate whether these are psychological effects of isolation, polar stress, cabin fever, or sensory deprivation. But that doesn't explain the heat signatures, the melted wires, the missing machines. Some even say the continent may contain zones of electromagnetic distortion, the result of buried minerals, cosmic interference, or something deeper. Perhaps even man-made structures reacting to environmental changes, or sending out signals that interfere, that delete, that resist being watched. You rise from the tripod base and brush your gloves off. The wind kicks up again, stronger this time. The snow stings. You turn away, but in the distance, through the haze, you think you see a shadow. Not a person, not a machine, just movement. Gone in a blink. You know better than to chase it. Instead, you mark your location and begin the slow journey back toward camp. Your thoughts filled with the weight of everything you haven't seen and all the things that used to be here now gone. The beacons were just tools, machines. but they were also eyes watching the ice, listening to the ground. And something down here doesn't like to be watched, so it watches back. And sometimes it reaches up and turns off the lights. You don't speak much as you walk. Not that there's anyone to talk to, only the wind and the snow, and the slow, groaning creak of distant ice shifting its weight after centuries of stillness. This is it, the edge of the map, not the coast, not the border of any nation, just the place where curiosity runs out, where instruments fail, where teams are recalled, where flags are never planted, and questions are quietly avoided. You've arrived at the place of no coordinates. That's not its real name, of course. Officially, it doesn't have one. It's a stretch of interior ice that's been deliberately left vague on most survey documents. Satellite imagery exists, but resolution drops sharply. Data is redacted or simply absent. It's not restricted, at least not openly, but expeditions that propose routes through it tend to change plans. They say it's too dangerous, too remote, but remote is kind of the point out here, isn't it? You stand atop a ridge now looking down into what should be an ordinary glacier field, but nothing about it feels ordinary. The terrain dips strangely like a bowl pressed into the ice by an invisible hand. The snow is smoother than it should be. The shadows are wrong, subtle but wrong. The silence here is different, heavier. Antarctica is known for its silence. But this is like the air has stopped moving. Like sound is being absorbed instead of echoed. Like you're inside something. The GPS in your pocket flickers once, then dies. No surprise. You take one careful step forward, then another, and suddenly, no warning, no sound, you're falling. Not far. Just a few feet. The snow beneath you gave way into a shallow depression. But it's enough to send your heart racing. You scramble upright, brushing frost from your jacket, and then you see it. Not a structure, not a body, not anything you can name. Just a surface, a slab of something buried under the snow. Smooth, angular, not ice, not stone. It reflects light too well. The snow that landed on it doesn't melt but doesn't stick either. It just slides off. You crouch, brush your glove across it. The surface is cold, much colder than the air around you, but it's dry. Perfectly dry. No frost, no condensation. You look closer. There are no seams, no rivets, no etchings. Just one massive seamless expanse sloping downward into the glacier, like the side of a ship that forgot how to surface. You tap it. The sound is wrong, not metallic, not hollow, just deep, like knocking on something that continues for miles in all directions. You check your radio. Static. You're alone. And you've found something that isn't supposed to be here. Some say the last thing we'll discover in Antarctica won't be a fossil or a microbe or an ecosystem frozen in time. It'll be a contradiction. Something that shouldn't be here. Something that rewrites assumptions. Not loudly, not with fanfare, but with quiet, undeniable presence. Something like this. You feel it now, not fear, exactly, but recognition. Like your body knows on some ancient level that this isn't just ice. It's a vault, and it's been closed a long, long time. Historians still debate whether we're ready for what lies beneath this continent, whether we can be trusted with secrets older than memory, whether some knowledge is meant to stay frozen. But Antarctica, it doesn't care what you believe. It simply is. And it remembers everything. The winds begin to rise now. The snow picks up. The edges of the slab are slowly covered again. Soon it'll vanish. Just another curve in a glacier. Another forgotten shadow in a place already made of them. You step back, heart thudding, not from fear, from awe. You don't know what this is. You may never know. But for a moment, just one, you've touched something that doesn't belong in this world. And it didn't reject you. It didn't open either. It simply waited, and it still is, because Antarctica isn't finished. Not with you, not with any of us, not yet. And now, as the winds calm, and the last traces of aurora fade from the polar sky, you settle back into the snow, your breath slowing, your body still. The questions echo softly, just beneath the ice, beneath memory, beneath the surface of things you thought you understood. You've traveled through forgotten ruins, locked beneath glaciers, followed phantom ships across oceans of silence, and touched anomalies that science dares not name. You've felt the breath of volcanoes that never erupt, walked across mountains no one has ever seen, and stood over lakes older than civilization, their secrets sealed tighter than steel. You've met the microbial titans of deep time, the quiet architects of survival, and glimpsed skyborne signals that may not be meant for us at all. You've stared down at alien geometries and up into blinking auroras that pulse like coded messages sent maybe from within. And in the end, the greatest mystery of Antarctica isn't what it hides, but how patiently it waits. Because this place doesn't resist discovery. It simply ignores it, a continent wrapped in silence. Not a prison, not a grave, something else. Something living, watching, listening. And perhaps remembering as your eyelids grow heavier and the warmth of your bed begins to claim you, you understand now that the deepest cold doesn't come from ice. It comes from knowing that the world is still full of locked doors, and that Antarctica may be holding the keys. So rest now. Let the mystery fade. Let the ice cover the trail behind you. No need to run. The cold never chases. It only calls. And tonight you listened. Sleep well, explorer. Tomorrow is for questions. But tonight we dream.